Looks like I need to update my preferences. Give me 1 minute.
No worries.
I'll leave the event and join. Okay.
Yeah. Apologies for that. Where we are starting now. Okay.
Yeah, I'm back.
Okay.
Yeah, I think you need to give my share presentation. Okay.
Yep.
Perfect. Cool. Thank you. Perfect. Welcome everyone for this session. So let's start with a quick question. How many of you have heard about TAConnect bot or used TAConnect bot? You can just quickly raise your hands. I want to see the how familiar our audience is with the TAConnect bot concept.
Either you can say yes or no. That's the preference you might have. Yeah.
Okay, so looks like a lot of people haven't heard about it, so which is good. I think this will be a completely new session to you. So what we're going to do today, from an agenda perspective, is we're going to give a quick introduction of what TAConnect bot is all about, how you can and how you can access the actual bot, and then we'll actually do a real live demo of the concept. And some of the features are not demoable, so we'll actually show you a quick view of how the different conversation dialogues between the bot and the customer. And then we do have a call to action. The call to action primarily is, as partners, you work with lots and lots of customers. So if you could take some of the collateral that we have and share with your customers in the next visit and educate them about the TAConnect bot, so that you can benefit and also your customers can benefit by saving lots of time. So now let's get started with the introduction. So what is TAConnect bot at a very high level? It is a self-service experience that is designed specifically for you. About 2 years ago, a lot of the common case management tasks had to be performed by calling our toll-free numbers, right? You have to remember the toll-free numbers, and whenever you need a new engineer or whenever you need to escalate a case, a lot of these tasks had to be done manually by calling in. But what we have now done is we have created a personal assistant called the TAConnect bot that you can use 24/7, and it is always available for you. And it's easy to access and easy to use. And 90% of the case management tasks, you can now literally do it through the bot without calling our 1-800 number. So that's the key advantage, where you can multitask things and not be waiting on a phone for the next engineer to be becoming available. So let's take a quick peek at what are the different features that the TAConnect bot offers. What are the different tasks that you can do? At a very high level, the different tasks can be grouped into 5 main categories. First is, as a customer or as a partner, you can look up the status of the cases, bugs, and RMAs. I know some of you have cases with TAC, but sometimes it might take like 5 or 10 minutes to completely go through all the case notes and come up to speed. But now what we have done with the bot is you can get a quick 1-minute summary of what the case is all about. And this includes both the key contact information and also the technical information about the particular case. And similarly, you can get 1-minute summary of a bug and an RMA. You can also use the bot to update a case. The nice thing about the bot is you can access it either through web or through support case manager or through Webex. So right from Webex, you can update a case note, upload a file, or let's say you're waiting for an update from an engineer, you can actually request a quick update and that will notify the engineer that you're requesting an update. Another new feature that was introduced recently is the ability to subscribe. A lot of the times you're interested in one of the cases that your company has opened with attack, and you don't want to keep on going back and looking at, hey, what is the latest update? It might be a case that is managed by your team that you want to keep an eye on. And now you can actually subscribe for updates. And whenever our attack engineers update the problem description, action plan, and the current status, the bot automatically notifies you and will say, hey, customer, this particular update has been made by the attack engineer, so that it minimizes the time of going back and forth. And then the fourth category is the connect feature. And a lot of the times customers spend trying to do ping pongs from the perspective of, hey, is the engineer available? Can I talk to them, etc. Like there'll be phone ping pongs going back and forth. Whereas in the case of the TAC Connect bot, all you have to ask the bot is, hey, can you connect me to this engineer in the context of this TAC case? And then the bot will in real time check the availability of the engineer, and this will take care of whether they are in the office, whether it is during their working hours. And then if all those conditions satisfy, then it'll check the real-time availability. And if they are available, it'll automatically connect you with the engineer. And similarly, you can also change the communication preference of a case from email to virtual space. A virtual space is a new concept that we've been expanding to multiple technologies now, where you can use the Webex as the messaging channel, as the primary messaging communication channel with TAC. So instead of email, you can use a Webex space to collaborate with the customer, with the partner, and the TAC engineer. And the last part is where a lot of the productivity gains come from, where let's say you want to schedule dispatch a case, like you want a particular engineer at a particular time zone during a maintenance window, you can request the bot to do that. And then at any point, if the severity of the case needs to be raised, you don't need to call 1-800 number. You can just ask the bot. The bot will ask a couple of questions, and then it'll connect you to the current engineer, or it'll connect you to the TAC frontline, who will then find the next available engineer and connect. And similarly, you can also escalate the case through the same bot itself. So there are multiple ways to access the bot. So it's available through different channels. So the easiest way to get to it is just go to tacconnect.cisco.com, and there you can click the chat right here option, or in the chat in Webex app option. Chat right here basically opens up a quick chat widget right within the same browser, whereas when you click the chat in Webex app, it creates a one-to-one space, and we will see this in the demo. The second option is going to Support Case Manager. The bot is natively integrated with Support Case Manager, which is the primary tool that our customers use to open cases of different severities. So within the Support Case Manager, you can talk to the bot in the context of a particular attack case. And this is a primary channel through which a lot of customers interact with the bot. And then the third one is a new type of integration called virtual spaces. So whenever you choose your communication preference as virtual room, it automatically creates a space. It brings the customer, the partner, the TAC engineer, and also the TAC Connect bot is also part of that same space. So in addition to having this human-to-human collaboration, you can also have a human-to-bot collaboration right within that Webex space itself. Irrespective of what channel that you choose, you'll get a very nice welcome message that clearly articulates what the bot can do and cannot do. Primarily, the bot is focused on the case management domain. It's not a technical knowledge bot, so it won't answer technical questions, but it'll help you do most of the things with case management related work. And it also teaches you on how to ask these different questions, so that you don't have to like learn or look at a lot of things before starting to use the bot. You can just right away get started. There's a couple of prerequisites. So whenever you access the bot using your Webex app, so in Webex app, you log in using your email address, right? So that email address should be the primary email address that is associated with your Cisco.com profile. And you might be asking, hey, why is that so? It's mainly because we want to protect your data. We want to protect our customers' data. And it is by that mapping between that email address, we identify who you are from a Cisco.com ID perspective, because all our bug, RMA, and case data is all tied back to the CCO ID. So that's why it's very important that you have the primary email address as the address that you use to log in within the Webex app. And then in certain organizations, they have blocked, some of the customers would actually block the bot interactions with external companies. So if that's the case, make sure that you enable two specific bots that we have listed here, the tac.connect at webex.bot and Cisco TAC-Spark at webex.bot. So once you enable, basically whitelist them, then you can actually start to interact with these bots, even if all other bots are disabled within your organization. So now let's go to go look at a real live demo. And one thing I wanted to also share with you as partners, you can also share the YouTube playlist or the Cisco video playlist with your customers. And each of these videos are very short videos, like about 2 minutes or 3 minutes, and sometimes just a minute, that focus on the different features of the bot. And so that whenever customer needs a thing, they can quickly look at the demo or just look at the help commands within the bot and get started. So let me share my Firefox here. Give me a second. Share application. And then I'm also going to share my Chrome, and we will also use the Webex app. So I will make sure to share that as well. Second. Okay, so we got this one, this one. Okay, and I'm going to share the Webex app. Okay, so I think you should be seeing 3 apps. So now let's take a quick view of the customer's view in Support Case Manager. So this is a test customer account. So this customer has a lot of cases, and we can interact with the bot in 2 different ways within Support Case Manager. One is outside the context of attack case, and another one is in the context of attack case. And let's try out the in the. So when you click the Ask the Bot icon, it launches the interaction with the bot in the context of that particular attack case. And the nice thing about this one is it gives you a quick view of the different. Let me make sure what is going on here. I might have to, the session might have expired. Let me quickly refresh it. Okay, let's bring it up. Okay, let's do a quick try in Chrome to see what's going on. Okay, here we go. So it might be some browser issue there. So when you start the interaction in the context of a particular attack case, so what you'll get is a quick view of the different things the bot can do. So there's like easy, quick links for each of these bots. So the other thing that you can also, the bot also does is it automatically enters the case number. And then once you enter that case number, what it is going to do is it's going to give a quick summary of the particular case, like a quick 1-minute summary of the case. And that will have very key information about the case owner, the point of contacts, the particular owner's manager, their point of contacts, the list of bugs, etc. And then one additional thing you'll also see is it's not only just the contacts, but it also gives the latest technical update that is associated with the case. So here you will see the latest problem description, the current status, and the action plan. And if the problem is already resolved, you will also see a resolution summary of it. Now, one of the other things you'll also see is a concept called contextual tasks. So depending upon So depending upon the type of the case, whether it is open or whether it is closed, you can see different tasks appear. So one of the tasks that I'm going to do now for the demo purpose is called the connect to engineer. So I want to talk to the engineer of this case, and once I click that, it's basically asking whether how I want to connect with the engineer, whether it's a phone or it's through a virtual meeting. So I'm going to choose phone here, and when I choose phone, it's going to ask for my cell phone number. So I'm going to quickly use my number here. And now what's happening in the background is the bot is actually checking the availability of the engineer in real time. So if I go to my the TAC Connect bot, so I will get a notification whether whether I'm available to work with this customer or not. And then once that notification comes in, then I can say yes or no, and based on that, the system will connect with me, with the right people. So that's a quick view of how the connect to engineer actually works. So now another view of this is where you can also interact with the bot using the chat and Webex option. So here in the chat in Webex, so when you click that link, it creates a one-to-one space between the bot and the end user, right? And this creates a quick one-to-one Webex session. And at the end of it, what you will see is you'll have a Webex desktop link or a Webex link where you can connect. And once that space gets connected, what you will see is a quick view like how this is shown here. And here you will see a lot of the first thing that you will see is a quick welcome message where it'll show the different type of tasks that you can perform. And then you can also look up certain things. So similar to the cases, you can also look up a status of a particular RMA. So when you look up a status of an RMA, what you see here is the key acknowledgement contacts, the ship to contacts, the shipping address details, the tracking details, all that in a quick 1-minute summary that's available. You can even look at the tracking URL of it, right? And now at any point in time, if you have a quick clarifications on, hey, what are the different type of commands that the bot will support, you can type in /list commands, and that will show you the complete list of commands that's available. And at any point in time, if you run into issues, or if you want to give like a quick announcement request, you can do /feedback, like you can just say bot works. And now that same /feedback can be used for both case-related feedback and bot-related feedback. So the bot will ask, hey, do you want to do it as a case or for a bot feedback, and you can choose one of them. So that's a quick demo of the different features the bot offers. So now let's quickly walk through some of the conversations that we didn't see in the demo, but we'll actually see it in terms of the conversation dialogues. So one of the new features that we recently introduced is the ability to subscribe to a particular case. So all you have to do is type in a favorite and then just put the case number, or you can look at the case status and then choose the mark the case as favorite option. And once you choose that, what is going to happen is the system will remember you, and then whenever there is an update on that case, it'll automatically send you that notification saying, hey, the current status was updated, or the action plan was updated. Another interesting feature is sometimes you may have like a few of these favorite cases and you don't want to look up one status at a time. And you can just say, show me the status of all my favorites. And in those cases, it'll pick up the most recently updated 3 favorite cases, and it'll show you the summary so that you don't have to type the command 3 times. It'll just quickly show you the status of the 3 favorite cases. You can also use the bot to add participants. So let's say, so Guru Rajan is one of my team member. I want him to get all the email notifications, or I want him to add into the virtual space. You can just say /add participant, and that will add that person to the case so that they can be part of the communication chain. And if you're a Webex app user, you can pretty much update the case. You can upload files all through the bot using a Webex app. It's super easy. All you do is update the case and then put the case number, and you just talk in natural language and the bot will understand. And then it'll ask you to give you the message that needs to be added or the file that needs to be added. And you can even combine both of them together as well. Another feature that gets significantly used is requesting latest updates. So if you're waiting on an engineer and for some reason you didn't hear back, then you can just pretty much say, hey, request latest update. And then the engineer will get notified like this, and then they'll immediately reach out to you with the next update. And then one of the things Stack does is we always do a 3-strike rule. Like before we close the case, we want to make sure that the solution is working and the issue is resolved. So we always want you to provide confirmation. So typically that work happens through emails. But if you're having a Webex app or with an SCM, you can at any time give a confirmation to close the case, and that will notify the engineer, and the engineer will take the actions to confirm the case so that you don't have to do this email ping pongs back and forth. So we talked about the connect to engineer functionality, and one of the new features that was introduced in the last release is called the request to join a virtual meeting. So here, when we do the connect to engineer, you now have a new option called virtual meeting. And this is primarily useful when you have an ongoing troubleshooting meeting that's going on and you want the engineer to join that meeting. So then you could pretty much provide the meeting number or the password or the meeting URL, and then we'll check the availability of the engineer, and if they're available, they'll join the meeting. So now let's take a quick look at another form of communication. So the connect to engineer primarily is a callback, right? It's a phone callback or joining a virtual meeting. A new communication preference is called the virtual room or the virtual spaces. And you can use the bot to change a communication preference. So all you do here is do /create space and just put the case number. And the system will change a communication preference, which will then trigger our case management system to automatically create a Webex space and invite all the case contacts and the TAC engineer. And then from there on, you use the Webex space as the primary communication channel for all troubleshooting purposes, right? So you can exchange messages, you can share files, you can start a meeting, you can schedule a meeting. Everything is done right in that one single central space. And the nice part about it is the bot is also part of it, right? So let's say you want a new engineer for this particular thing, or you want to schedule dispatch this case, you can just do it right from the Webex space itself. So here's some few things. At any point, you can use the add participant command to add new people into the virtual space. And what the bot will do is it'll first check if that user is authorized to that case. If it's not, then if you have access to the case, you can override and provide access to it. And then you can also share all the files. The files that you share up to 300 megs are automatically uploaded to the TAC case without you copying, downloading it, and uploading it, etc. It's a seamless experience. And when the case gets closed, the virtual space also gets closed. So that way you don't have any stale Webex spaces in your app. So it's the life cycle of the space is directly associated with the life cycle of the TAC case. And at any point in time, so let's say the engineer has requested you the information and you have provided that information through virtual space, you can also change the status of the case to indicate to the engineer, hey, I've provided all that information. Typically, engineers will just look at the Webex space and they'll know. But if you want to make sure that the status also reflects, maybe from customer pending to Cisco pending, you can also change that right through the bot itself. And then when the case gets closed, all the transcript of that conversation is added as case notes within the case. And from within Support Case Manager, you can go to this Virtual Spaces tab, and then you can click the transcript, and then you can completely view the end-to-end transcript of what happened in that case. So even after the case is closed, you have access to the transcript. So now let's take a quick peek at some of the very common workflows that you can, or tasks that you can do using the bot. The first is a raise case severity, and the key concept here is at any point when you do case severities or requeues, we always try to connect you with the current owner, because we don't want to connect with another person so that you don't have to restart telling all the processes, all the information about your problem. So we try to check the availability of the owner. If the owner is available, then we'll connect them with it. Or if the owner is not available, the bot will automatically call the TAC frontline, and the frontline will give you a call back, and then it'll find the next engineer to work with you. So similarly, on the requeue case, if it's a CEF3 or a CEF4, the system automatically performs the requeue, but if it's a CEF2 or a severity 1, it connects to the TAC frontline, and then it'll find the next available engineer. You can also schedule dispatch a case. So imagine that you're a customer in APJC and you're working with an engineer in Americas. You can request an engineer in your local time. All you have to do is put your date, your maintenance schedule dates, or the time slots, and the time zone, and then the case will get dispatched. There's a couple of options for escalate. I've got all the different scenarios here. So you can escalate a case, and what will happen is the bot will first try to check if the case owner's manager is available. If they are, then they will reach out to you. If they're not available, it'll reach out to the on-shift duty manager. And then if the on-shift duty manager is not available, then it'll reach out to the 1-800 number, and the customer service representative will call you. So in all of this, all you have to do is request, and then the bot will perform all these tasks automatically for you in the background. You can request the person to contact you either via phone or through email, and then the system will perform all different availability checks. So the email is primarily used for non-urgent escalations, whereas the phone is actually used for urgent escalations. And if you're a premium customer, the nice thing about it is the bot will also inform your high-touch operations manager so that they are aware of the escalation request that you have submitted. In terms of help and feedback, and there's also a really nice feature where if for some reason the case got closed because we couldn't reproduce the problem, but the problem reoccurred, and now you don't want to start with a new engineer, you can basically ask the bot to reopen a case, and it'll, within the 14 days, and then the bot will reopen and it'll inform the engineer so you can continue troubleshooting process. So we did talk about helps and commands. So in terms of, because we have a short time, I'll quickly go through how to keep up to date on what are the new features that's available through the bot. At any point in time, we'll have this release note section that'll with the red dot. That means a new release has been released and that has new features. When you click that, you will see a complete list of new features that has been released in that particular month's release. So we have a monthly release. But if you're a Webex app user, you don't have to do anything. The bot will automatically notify you through Webex app saying, hey, I just got upgraded. Here are the new things that I can do. And here are the new bug fixes that has happened. So that concludes our session, and our key ask of you is take the time to use TAC Connect bot and save time, and also educate our customers about it. We have a really good amount of collateral, both in terms of video playlist and also PDF documentation in the links. Customers love the bot, and one of our customers actually wrote a blog by themselves without even me asking on how useful it is. And then during the COVID times, the bot has been really, really helpful because it helped a lot of customers have self-service experiences, and thereby enabling our TAC frontline team to focus on a lot more customers on complex issues, and help everyone be productive during this pandemic. So we have all these sessions. At any point in time, feel free to reach out to us using the tac-connect@cisco.com to report issues or things that you like or new features that you would love to see. So that's all I had, Guru Rajan. So let's take a quick peek at any Q&As that needs to be answered.
Yep. Thanks, Arun. That was really helpful. And please, team, please raise your questions on a Q&A session. Probably, Arun should be able to assist you with the answers. Okay. Thank you, Arun.
Thank you.
Arun, we're done with this session, right? So we can move on to the next one. Right?
Yes.
All right. Thank you. And next goes Multicast. Probably Ganesh or Prasad, who wants to go?
Yes, sure, Guru. Thank you.
Maybe I'll make you presenter, Prasad.
Sure, please.
Team, please raise your questions, any questions on TAC Connect bot on a Q&A sessions. We should be able to assist you with that. Thank you. Over to you, Prasad. Thank you.
Yeah, thank you. So are you able to see the slides?
Yes.
All right. So let me see if I can switch to slideshow mode. All right. So I'll be talking about SD-WAN multicast primarily in this session. We'll go over the multicast overlay service that's being offered to our customers on the SD-WAN product lines. So yeah, the objectives primarily to share details about multicast, and then we will have a very detailed demo on how the inner flows of the multicast are constructed and the trees are built. So yeah, the agenda will cover the architecture overview, where we will try to go into the details of how SD-WAN multicast is implemented on the C-Edge and the V-Edge platforms, how things have to be deployed, what are the considerations. We will talk about some greenfield and brownfield perspectives. We have a demo about that will explain essentially the architecture in working. That is basically, we will go through the flows in theory first and then demonstrate them exactly on a real router. And then we'll have the wrap up. So diving into the architecture, right? So this is probably a standard diagram that you have been already familiar with, where basically the Cisco SD-WAN service connects any deployment, any service to any transport to any location. The point to note about multicast here is that multicast, especially multicast that is spanning across different SD-WAN sites, require some special considerations to be done because of the nature of the connectivity that is offered here. Because the different sites can be connected via satellite, internet, or any kind of WAN connectivity, or the traditional MPLS circuits. The multicast has to be revisited from that perspective, where the heterogeneous nature of the WAN connectivity needs to be taken into account. Arun, I'm sorry if you can mute yourself, Arun. It's okay. Sure. Thank you. And also the fact that your receivers can be connected on the public cloud, on the data center, or it could be on the private branches, right? So we will talk about the two main points that multicast needs to be supporting. That is basically provide a one-box solution where your multicast tunnels and SD-WAN tunnels originate and terminate from the same box, and the replication is decoupled from the physical topology. That is a very important aspect that we will go into a lot more detail. But this slide just kind of gives you the overall motivation as to why these these use cases have to be addressed. So yeah. So the point to note here is the SD-WAN multicast architecture is very much in sync with the SD-WAN unicast architecture, and it essentially uses the same control plane and data plane components that the unicast architecture would use. For example, in the physical layer, if your C-Edge is using TLOCs, then multicast is also designed to work on TLOCs. If in the unicast routing protocol on the service side, you would use BGP or OSPF. Then you can use the same protocols for your unicast connectivity to be feeding into the multicast route lookups. Of course, it goes without saying that PIM, which is the standard multicast protocol that is being used on the internet, can be used on the service side. Now, all of this is now tied to the OMP protocol in the backend, and all of these feed into the OMP. And again, on the SD-WAN control plane, we use the same entities of vSmart and OMP, to go and construct the multicast trees. So the point really to be made here is that multicast, does not require a new kind of an infra. Multicast relies on the existing OMP control plane infra, the TLOC data plane infra, the IPsec GRE tunnels that are normally used between the sites, and therefore multicast has been built ground up using the same infrastructure, so that you have a single pane of control to do both unicast and multicast routing. In other words, you do not need a separate set of protocols for doing unicast and multicast. Of course, PIM being the only addition here, that is naturally the case, because the PIM is the standard multicast protocol. But all the other components that are used for the unicast routing are exactly reused for multicast routing, and this gives us the power to build or leverage on the unicast infra that has already been deployed and built by the customers. So what are the use cases for multicast SD-WAN here? Right, the multicast SD-WAN, typically operates on a few, dictums, if you would want to call it that way. That basically we have to have a large number of spoke sites, which are receivers, basically where branches have receivers only. That doesn't mean that the branches cannot have sources. There are no restrictions for having the sources. They can be anywhere, but typically you would expect the branches to be, having receiver only capabilities. The source can be at any site. It doesn't have to be at the headquarters or at a particular site. It can be at any site. There are no restrictions on having the source. The most important aspect would be the RP placement in a multicast network design, right? So we will look at this in more detail, but at a very high level, the current multicast design allows you to either have a dedicated RP for the SD-WAN fabric or reuse the existing enterprise RP that is already being deployed in existing networks. We understand that the multicast networks that are already built that do not work over the SD-WAN still have to share the RP, and we would want to keep those RP nodes there. The replication of multicast needs to be offloaded to more powerful boxes at a distribution site. We will come back to this. This is probably the linchpin of this presentation. We will come back to this point, in detail later. But it suffices to say now that you want replication to be done at a point that the operator chooses to do it, rather than the point at which the network wants it to be done. We'll come back to this point in a lot more detail. And of course, for load balancing or redundancy purposes, you would want those replicators to be chained or hierarchically clustered, so that your scalability increases or your redundancy increases. And you would want those replicators to be autonomous of each other. So these are the multicast use cases that we keep in mind. Of course, I would just briefly touch upon the previous slide that in addition to all these requirements, we use the same entities as the vSmart, the OMP entities, that are available for unicast, right? So what is different, in SD multicast? So SD-WAN offers software-defined multicast, and what is it that it is different, or how is it is different from the traditional multicast? In a traditional multicast, your replication is defined by the physical topology. For example, if all these routers are connected in a LAN or in a network, I should not say LAN, it should be connected in a network, then basically if the source is behind A and then you have receivers anywhere, right, then A would have to make 2 copies of the packet that is indicated by the red arrows, and then each copy goes to B and C, and then B would have to make 2 copies indicated by the green lines to D and D, and C would have to make 3 copies to reach F, G, and H. Now, the points of replication and the replication load, or the amount of replication done at each node, is defined by the physical topology. The software has no control whatsoever in determining where the multicast happens. By nature of the physical connectivity, I have to make 2 copies at A, 2 at B, and 3 at C by virtue of the receiver placements. Of course, if you were to bring in the RP, those semantics may differ, but the fundamental notion of the points of replication and the amount of replication being done are essentially being driven by the physical topology. Now, this is probably topology driven multicast or topology defined multicast, which is the traditional way of doing multicast. In the new software defined multicast, you would want to pick the points of replication and do the replication at those points for a select set of nodes. So for example, if C, D, and E were geographically close to B, and it makes more sense for B to do the replication for C, D, and E, then by software definition, I should be able to say that I will pick B as my point of replication for C, D, and E. For F, G, and H, it could be another node, which is probably not shown here. You probably want to pick another point of replication. So the idea here being the amount of replication and the point of replication, be defined by software rather than being defined by physical topology here. So that's the central idea of the software-defined multicast. So you truly define multicast in a software-defined way and say, okay, I will choose my points of replication, namely being X, Y, and Z, and X will be catering to, 100 branches, Y will be catering to 200 branches, and Z will be catering to 400 branches, and so on. So I will essentially decide, okay, my points of replication are going to be X, Y, and Z, and the replication load at X, Y, and Z is going to be, alpha, beta, delta, whatever, right? So now it would be nice to do all of this using the same control plane, that is the OMP, and the same policy entity, that is the vSmart, so that all of the unicast information that is being done for the routing is also being reused for the multicast. That is the central idea of the software-defined multicast that we do here. So we introduce a new entity that we call as the replicator. The replicator is not the RP, is not the first hop router or the last hop router. It's a separate entity. Of course, the replicator can co-reside with the RP, can co-reside with the FHR, or can co-reside with the last hop router. In other words, the replicator can have a source behind it. The replicator can also host the RP. The replicator can also have a receiver behind it. There are no restrictions there. So moving on, we want all of this to work with the same security zoning, the compliance, the multi-tenancy, right? The multicast fundamentals that we laid out should not apply to only one customer. It should be applied to one customer at a time. And there should be the segmentation that we would also want to use, that we use for the unicast. And so all of that applies to multicast. The, the different methods of connecting, whether it is a single full mesh or whether it's a partial mesh, there should not be any restrictions that multicast would suffer because of these kinds of connectivity. It should seamlessly work with all kinds of physical topologies, and multicast does support all of this. The security, last but not the least, the same security policies that you would apply for the unicast would also apply to the multicast traffic. So, this is just a very small segue to say, there is nothing different that you do for unicast and multicast. The way you would bring up a SD-WAN fabric for unicast is the same way you would bring up the multicast fabric. Of course, you would need additional configuration steps for multicast. So at this point, I will go into the details of what a replicator means and how a replicator is functioning, and the route exchange sequences. And then Ganesh will reinforce that later when the demo happens. We will essentially revisit what we discussed in theory and exactly show the route flows that we discussed in theory. But before going into the details, I would like to take a brief moment and then summarize what we have discussed so far. We have achieved the architectural consistency for multicast overlay by reusing the same components that we use for unicast, and also reuse the same MVPN implementation that we had done for the BGP MVPN, so that it is very close to the standard as possible. The OMP semantics are very compatible with the BGP semantics, and the constructs of the OMP, as you would go through, you will realize that it will be very similar to the BGP MVPN, and therefore it is widely understood by the industry. And those semantics are built on, a robust brainstorming, a lot of implementation experience that has gone through, and that contributes significantly to the stability of the multicast design. That's the point that I want to reinforce here. That is, we are not inventing something new, although the way of multicast that we are doing is completely new. Basically we are doing software-defined multicast with a new approach or an architectural, thought process to the way multicast has to be done for the SD-WAN, but reuse it. The same components gives us the leverage of, retaining the stability and time-tested, use cases that have already been deployed and multicast and troubleshooted. We don't want to reinvent the wheel in that case. Multicast also supports the TLOC extensions for redundancy. So therefore, whatever physical redundancy you may already have realized for unicast with the TLOC, that again works for multicast. A very important point to note here is that the investment protection for the vEdge interoperability, the multicast that runs on cEdge, is backward compatible with vEdge, and therefore existing vEdge nodes can work seamlessly with the new cEdge nodes that will be deployed for multicast. So that is a very important aspect here. The investment protection is fully guaranteed. Of course, the standard mechanisms of the RP selection, whether it is auto RP, Cisco auto RP, or the static RP provisioning, or the PIM BSR, are supported by SD-WAN Multicast, and we should be able to leverage those RP configuration or selection mechanisms. So this slide is going to be a very detailed walkthrough of how a receiver and a source is going to join a multicast stream. And I should thank Hassan for preparing this slide. Hassan is also on the call, I believe, and this will illustrate the exact control plane sequence. And this control plane sequence is what will be replayed by Ganesh in the demo in a practical way, where we will demonstrate the same sequence so that we get the flow understood by all of us. So I will start with the receiver. The receiver traditionally sends an IGMP join to the last hop router. There could be intermediate routers connected between the last hop router and the receiver. I'm just showing it to be directly connected here for simplicity's sake, but it need not be the case. The receiver can have, can attach to a traditional router, which can even then lead to the site CH. So there can be a L3 network between the LHR and the receiver. It's supported. Now, the IGMP join gets converted into a PIM join internally into the LHR, but the PIM join is really going to go out as a StarG join that is equivalent to the BGP route type 6 in the MVPN world. Traditionally, it would go to the RP, but the software, because the SD-WAN would do it in the software way, the multicast is being done in the software defined way. The LHR does not send the join to the RP. Instead, it sends it to the replicator. Now, how is the replicator chosen? There are a variety of ways to choose the replicator. It could be based on your GPS location. It could be based on some parameters defined to select the replicator, threshold parameters, and then every replicator can handle certain amount of load. So there are some guidelines on how the replicator is chosen. We will not be going into the details of that. But the point here is that is completely defined by software. That's the central point to make here. What replicator is chosen by an LHR is defined by software routing policies and not defined by the physical topology. That's the point I want to make here. Okay, once the replicator gets the join, of course, it's going to send the join to the RP, because the StarG join is always terminated to the RP. And this RP can be elected via PIM BSR, or can be elected via the auto RP, or can be statically configured. Right now, we'll just assume it as a statically configured RP for understanding purposes, and I will just redirect join to the RP. Now, here the RP is shown on the CH. In certain topologies, especially for statically connected RPs, the RP need not be on the CH. It can also be on a PIM router behind the CH. The slide shows it to be on the CH for simplicity purpose. Okay. Now, at later point of time, when the source starts streaming traffic, the source could be in a different site. Of course, it's not in a site belonging to the replicator, the RP, or the LHR. Again, I just want to emphasize the fact that we are just showing the entities to be located on different sites for simplicity purpose. The replicator could also have a receiver behind it. The RP could also have a receiver behind it. There are no restrictions there. We are just showing this diagram for illustrating the purpose here, but you could have receivers anywhere on any sites, any number of receivers on any number of sites. So at a later point of time, when the source is streaming the traffic, the source is going to do the PIM data registration to the RP. That's the standard procedure. And then the RP is going to use the StarG tree to send the traffic to the receivers that are located on the StarG tree. Now, at this point, two things will happen. Of course, we will, there are many possibilities here, but we will go to the possibility where the source tree, the source tree switchover happens and the SPT switchover happens here. Just to illustrate the sequence, the traffic goes over the StarG. The first packet is sent over the StarG to the receivers, and at that point of time, the StarG also joins the source specific tree. But if you notice the arrow number 6, instead of the RP sending the S-G join directly to the FHR, the SG join from the RP is now going to the replicator. Why is that? Even the RP is actually receiving traffic from the replicator. So if there were to be a receiver under the RP, then the RP will also be serviced by a given replicator. So all replication happens by software defined points that are called replicators, and they do take up all the replication load. Now, there is another point to note here. If the RP does not have a receiver behind it, then the WAN bandwidth is not wasted. The RP will prune itself from the source tree after the tree has been established. That is the normal multicast VPN operation, and that continues to exist because we do not want to waste the bandwidth over the WAN. So receivers or sites which do not have RP sites which do not have receivers behind them get automatically pruned from the tree later on. I will pause here to take a minute. If there is any point that you would want me to revisit, I will revisit this. Please let Guru know. Otherwise, I will proceed. I will wait here for a minute because I think this goes into a lot of depth, and I want to make sure that the points get digested before moving further. Guru, I'll pause here for a minute or so.
Sure, Prasad. Please raise your raise your questions on Q&A session or raise your hands if you have any questions. Yeah, probably we can unmute you. Yeah, thank you.
Yes, I think there was a question about the redundancy of the replicator. The replicator can be redundant. Although we have shown one replicator node here, the replicators can be redundant. There, of course, if you see in the previous slides, I would have given it as replicators. It's a bit difficult to go there right now, but replicators can be redundant. One replicator failing, then the star G joins or the SG joins get redirected to the another replicator. So that's. Thank you for asking that question. Definitely replicators can be redundant. There is no single point of failure for the replicator. Any further questions before I move on?
There is one more, Prasad.
Yeah, yes. Yes, I think the question was about, so will the traffic flow directly from the source to the receiver? No, so the traffic does not flow directly from the FHR to the replicator. The point of having the replicator intermediate between the FHR and the LHR is to do the replication at the replicator and not at the FHR. Why is that needed? Because it is possible that the FHR may be a site that has very limited capability or horsepower in terms of replication. Of course, you can have a situation where your FHR is also the replicator. For example, in this example, right, if you move the source from site 2 to site 4, it will still continue to work. The replicator and the FHR will be located on the same node. It is possible to do that. But in cases where your FHR, that is your first hop router, is not as powerful, then you can pick a replicator where you have the horsepower. So just to summarize, you can have multiple replicators. Replicators can be redundant. Therefore, when one replicator fails, it can take over. And a replicator can also have a source behind it, or the resource can be located at a site different from that of the replicator. Both are possible. It's just the network design you want to do it the way you want to do it. I will go to the next one. All right. So once the replicator joins the source, then as you can see, the source tree is now built through the replicator between the FHR and the LHR. Of course, there is a semantic called the source active route, which indicates, that's the standard MVPN route type 5, if you want to look at it, right? The purpose of it is basically to tell all these sites that I have a source S, G behind me, join if you want. Now that SA route is being advertised directly by the FHR, but the S, G joins will now go only to the replicator. So when the LHR joins the tree, source specific tree, it does not join site 2 directly, it joins it through the replicator, and all of the replication happens through the replicator. Now again, I want to just reiterate, the replicator need not be hosting the source in this example as the example shows, but there is no restriction that the replicator should not host the source. The source can also be behind the replicator. If you choose to have the source at a at a branch that does not have very powerful replication capabilities, then you pick a replicator at a different branch that has the capability that will take up the offloading work. If the branch that hosts the source is powerful enough, then well and good, you can have it as the first hop router and as the replicator, no problem. And finally, the traffic flow completes through the replicator. Now, this is exactly the same sequence that Ganesh will revisit during the demo. You can see how the control plane flow happens through the different entities as Ganesh walks you through the different stages. Now, there is one more point to note here. The arrows, especially the control plane arrows that are shown in dotted arrows, are shown here as to be exchanged between the nodes. For example, when site 1 sends a *G join, that is the arrow number 2, it is shown as directly going from site 1 to site 4. Similarly, when site 4 sends a *G join, that is the blue arrow number 3, it is seen as a *G join going from site 4 to site 3. In reality, all of these route exchanges do not happen directly between the nodes, but they happen through vSmart. You should think about the vSmart as the BGP route reflector equivalent. And the reason why it happens through the vSmart is that you can enforce policy at that point of time to determine how the route exchanges happen. Now, I would just say that the policy can be enforced. At this point, I'm not going to the capabilities of the policy enforcement. Some part of it is in the roadmap. But the most important point to note here is that because your exchanges, although I am showing it here as being done, the exchanges happening to the entities directly, they happen through the vSmart, via the vSmart, and that gives you a policy enforcement point which can be used to tweak. For example, if you want to say at a later point of time that only few sites can join a particular *G, then you can implement such policies at those points. The architecture allows you to do that. That may or may not be supported today, but the architecture allows you to do that. That's the point I wanted to make here. All right. So I think we have done a good amount of heavy lifting on the architecture. Let's take a little bit of a breather and look at the feature metrics, right? Between the V edges and C edges, I said that the V edge investment protection remains, and the V edges can cooperate or coexist with interoperate with the C edges in the network. But there are some points to note, from the V edge perspective, where the V edge cannot be RP on a box, or the V edge does not support certain MSDP or PIM-BSR implementations because of the historical reasons. But the C edges fully support those things. But it is the point here to note that is V edges can still be acting as replicators. Certain models of V edges can be replicators, and it still supports the LHR configuration, or the FHR configuration. So the V edge can host a source behind it or receivers behind it, and those nodes can be reused. And of course, it does work with the auto RP as well. So this is more a wrap-up slide, kind of saying the different points. Note here, we did talk about the PIM-BSR model. I did touch upon it, right? So basically, the way we support PIM-BSR is that every site, sites which especially have large L3 networks, can elect their own RP using PIM-BSR. The only point to note is that the RP that is elected by the BSR should be doing it on the C edge. That is, the C edge should be configured with the highest RP priority and be made as the RP electable RP. So eventually, when the RP election happens, the C edge should win the election. That is because when you have multicast traffic flowing across sites, for the multicast streams that flow across sites, you would want the RP functionality to be on the C edge and not on the LAN router. If the multicast flow is for within the site, then there is no restriction on the RP has to be on the C edge. It can be anywhere. The other point to note here is that a very powerful construct that not all sites need to be simultaneously using BSR election. You could have some sites using static RP and some sites using BSR as well. So, for example, if you want to run BSR for the large sites, you can continue to do so, and PIM BSR. And if you want to run your static RP for the smaller sites, then you can continue to do so, no problem. I'm not sure, Guru, at what point the voice is breaking, but I will try to repeat if you mention a particular point you want to re-emphasize. I will try to talk slowly here. All right. So at this point, we will take a segue into the deployment considerations. So what are the considerations that you want to think about when defining a SD-WAN multicast network? So when you want to design a SD-WAN multicast network, I think the first point that you would want to think about it is it going to be a greenfield network or is it going to be a brownfield network? If it's a greenfield network, you have more degrees of freedom to design the network, but there are some fundamental aspects irrespective of whether it is going to be a greenfield or a brownfield network. Central to the multicast design is going to be the RP placement design and the replicator design, right? Now we should understand the roles played by the replicator and the RP are different. The roles played by a replicator, of course, you can have the RP and the replicator co-located if you want, but you have to think about the fact that, should the replicator be co-located with the RP? Should it be independently located with the RP? And where should be the number of replicators? I think a very good question was asked, what about replicator redundancy? How many number of replicator sites should be there? And what kinds of, or how many receiver sites should be, connected to every replicator? These are some standard questions that you may want to ask. Of course, the answers need not be, they will be very unique depending upon every requirement, customer use case. You may want to, think about these things, but these are the standard design aspects at least we could think about. The other aspect to really keep in mind is that all of the multicast design is influenced by the unicast routing. So if your route to source is via a particular replicator, right, then the way your unicast is designed also influences multicast. So we should understand that basically the multicast does not operate separately. Multicast rather relies on the unicast policies. And those are the aspects that you would want to keep in mind when designing the route policies or the site placements, the hardware that you would want to use for every site, the hierarchy that with which you want to configure your network. For example, if you want to consider a pan-India network, then you would want to consider regional sites for north, south, west, and east and central zones. And then under every central zone or your western zone or your southern zone, you may want to consider some regional sites. Where should those be placed? And then inside the regional sites, where should be the branches? How the fan out should happen, and those things have to be thought about. Another aspect to keep in mind is the V-edge interoperability. If you have existing V-edge nodes, especially in the brownfield network, then how would you want to use the V-edges? Do you want to have the V-edges as first hop routers or last hop routers only, or do you want them to be also replicators only? Certain models of V-edges are there. How the RP is going to be reachable, all those aspects will have to be understood. The other important point to note is the coexistence of traditional multicast and SD-WAN multicast, right? It's not that all of the multicast is going to be migrated to SD-WAN. Your traditional multicast still has to exist, and the handoff points, how would you hand off, at what site do you hand off? Those aspects have to be considered. And last but not the least, there is something called SPT only mode, where every site will terminate the strategy joins, will have an RP, and the RP could be elected via PIM BSR, or it could be done via the static RP. That is something that I have not gone into a lot of detail because that's going to be a little more advanced topic. But we can discuss that specifically offline if there are some specific queries on how to do SPT only mode. Again, this SPT only mode is a standard thing that exists in the BGP MVP, and it is just being reused for SD-WAN. Of course, another important aspect is the TLOC redundancy. Multicast does work with TLOC redundancy or TLOC extensions. So you can build in redundancy for the site, whether it is physical link redundancy or node redundancy. Multicast can be leveraged for that. Last but not the least, I think a few aspects to remember. IPv6 overlay multicast is not yet supported. All multicast that we talked about is a V4 only in the overlay and in the underlay. V6 is on the roadmap. We can discuss V6 aspects if there are some specific queries about V6. There are some restrictions with respect to policy, PBR, with multicast routing, how policies has to be used. There are some restrictions there. I think we can probably consult the guides for the details about these restrictions, but I'm just pointing them out. Again, we talked about the VHs. They can be configured as first hop routers or last hop routers, but not as RP. Certain VH models can be used as replicators. And dynamic BFD tunnels are not being supported for multicast yet. And for PIM BSR, the star G should be terminated. The CH we talked about it. The candidate RP should be elected as the CH should be elected as the candidate RP. So at this point, I'll hand it off to Ganesh. There will be a demo, illustrating the points that we discussed, and we'll be happy to take questions and revisit anything that you require clarifications. Ganesh, over to you, Ganesh.
Thank you, Prasad. Shall I share my screen?
Yeah, go ahead. I'll just make you presenter, Ganesh.
Yeah, thanks, Guru. Okay. Hi all. This is Ganesh from PA Multicast team. So now we are going to see the demo for the topology that we have discussed earlier. Okay. So I have a 4 CHs on 4 different sites: site 1, site 2, site 3, and site 4. Okay. So each CH will act as a different role here. That is, one will act as a replicator, other will act as an RP device, and other will act as an FHR. Okay, if FHR is the one which is connecting to the source, and then LHR device, that is which is having a receiver. Okay, so all the CHs I have used ISR 4K for this demo. Okay, then receivers and source are we have used XCF for the connection. Guru, am I audible? Shall I proceed?
Yeah, go ahead.
Yes, Ganesh. Yeah.
Thank you. So this is the topology that Prasad has showed. So now we are going to see how the routes propagation is happened when the LHR getting a joins from the receiver, and then how the if traffic comes, how the route propagation of RT5, RT7 are propagated to the devices, and then we will check how the MFIP statistics are incrementing and all. Okay. So now we can go to the console. This is my device. The FHR host name is FHR device. LHR, this tab is my LHR device, RP, vSmart. Also, we will check how the OMP routes are there once the system is converged. We will check how the star G and the HG joins are propagated here. We can check those via show command. And one more thing is we actually push the config via vmanage. Okay, due to time constraint, currently the configs are already applied, but XCI is not started yet. Okay, so maybe I can show the multicast specific configuration. Maybe I can go to the replicator device. Due to time constraint, we can't go push the config via vmanage, so it is already done. I am just showing the configs that are already applied. Okay. So in SD-WAN multicast, we have specified the address family v4 for this VRF1. And then I have specified the replicator, which means that this CH will act as a replicator here. Okay, so we currently for demo, we are using VRF1 alone. Okay, so this is the configuration with respect to SD-WAN multicast. If the CH is not a replicator, then we don't need to give this. Okay, so if we are giving this address family IPv4 VRF means internally it will give 4 commands with respect to ingress replication, something like a data MDT immediate switchover, and those VRF related commands that we have seen in usual VRF config. Okay, so here let me go to the multicast config. Okay, so this should be enabled. Okay, this is for overlay VRF group. We need to enable multicast routing, and then okay, for demo we have used static RP. As Prasad told, we can also have auto RP or BSR also on each side. But for the demo we have used static RP config. Okay, so this configuration we need to specify it on all the CHs, meaning 94, 94, 94 is my RP loopback, which is actually present in this RP device. Okay, if you check here, I have a 94, 94, 94 IP. So meaning I have configured this I am specifying this 94, 94, 94 as an RP on all the CHs for the VRF1. Okay. Okay. Now we can go to Ixia part. Okay. So first we can see how the RT6 propagation once the joins comes to the LHR, then we can start the traffic next. Okay. So this is my IX network where this is my receiver and this is my source host. Okay. I am planning to send IGMP join for 227.0.0.1. Okay. So this is an ASM group. Okay. I am starting a V2 join now. Okay. Got a green, so meaning we have got a join to LHR. Let me confirm this. Okay. So show IP IGMP VRF1 groups, and I am getting a 227.0.0.1 join, which is coming from this interface. Okay. If you check the show IP mroute VRF1 227.0.0.1. Okay. OAF will be always the one where we are getting the joins. So gig 0 via gig 002 we have get a star G join. Okay. Then RP we have specified as a 94, which is an RP loopback. Okay. Okay. Incoming interface and RPF neighbor. Now we need to check where the star G join should go. Okay. So LSP with via LSP with 0 interface, we have to go. We are going. This star G join will go to the replicator. Okay. So if you check my host name, 1.140 is my FHR, 1.60 is for LHR, 1.50 is my RP, vSmart, and then 1.180. These are all these are all 192, 168, 1.180, right? So these are all system IP of the each devices. Okay. So for replicator, the system IP is 192, 168, 1.180. Okay. So via this LSP WIF interface, this charge join should go to the replicator. Okay. So as Prasad told, how the RT, let me to go to the MEPIN command too. But this charge join first go to the replicator. From replicator, it will reach the RP. Okay. We can check each route propagation on each device. Okay, this is a MAPN command here. Okay, this RT6 for this group 227.0.0.1. Okay, my next stop is 1.180, meaning it is going to the replicator, and send colon 1 means it is actually sending. If it is send colon 0 means it is actually receiving. Okay, here we are sending the RT6 join, right? So for this group, I am sending an RT6 join. Also, we can check the OMP routes also. There you go. Okay, so for this star G, okay, so for this star G 227.0.0.1, my source is LHR device. Okay, and destination will be a replicator. Okay, so let us go to the replicator now. So IPM route VR of 227.0.1. Okay. Okay, we have got a star G entry. Okay, OAF will be the one where we are getting a join. This is an LSP WIF interface. Okay, RP is 94, 94, 94. To reach this RP, IAF will be the LSP WIF interface and RPF may be 1.50. Meaning this replica 1.50 is our RP device. Okay, so this is star G join will be reoriginated at replicator and will be given to the RP device. Also in SD-WAN world, okay, so the special cases usually in legacy multicast IAF and OAF won't be same here, whereas in SD-WAN world it is same. Okay, this LSP with is the SD-WAN cloud interface, right? So we are getting a star G join from here, and also we are going to send this star G join toward the RP from the same interface. This is a special case in our which won't be there in the legacy multicast. Okay, now I am going to check the MEPIN command. Okay, I was getting a RT6 join. I mean, from LHR I should have get the RT6 join. Okay, so from 1.60 send colon 0 means it is receiving a join. Okay, RT6 for this group 227.0.0.1. Okay, now what will happen is I have got an RT6 join to the replicator. Then this replicator will do the reorigination of the RT6 and it will be given to the RP. Okay, so maybe These are all internal commands. Okay, show IP pim VRF1 MDT internal, right? You need to enable service internal for this command to show. Okay, for this RT 227001, I am getting a RT6 from LHR. Now I am going to do the reorigination of this RT6. So the next stop will be 1.50, meaning this join will go to the RP now, send:1. Okay, so which means I am reoriginating that. Okay. Now we can go to RP device. IPM route 227. Okay. OF will be usually the one where we are getting a join. So LSP with interface, SD-WAN cloud interface where we are getting a *G join here, and then RP will be 94. Incoming interface null RP of neighbor 000 means it is a local RP. Okay. So we can also check the command. Yeah, here you go. So we have got a RT6 join for this 227001 group. Next stop 1.180. That is, I am getting a send:0 means it is receiving, right? So for from this 1.180, I am getting a RT6, that is *G OMP route from the replicator device. Okay. So we saw how the RT6 reorigination happened at replicator, and it is reaching the RP device. Okay. Now we can check with the traffic flow. Okay, so I am going to send you a traffic, and then we will see how the routes propagated, that is RT5 and RT7s are propagated in the device. Then we can check the MFIB stats and all. Okay, let me open my Ixia stream. Okay, here endpoint topology 1, I have only one stream. This is my source there. Okay, and multicast, my destination IP is 227.0.0.1. Okay, so topology 1 is my source, and topology 3 is my receiver, and I am sending a traffic from topology 1 to 227.0.0.1. Also, I am having a rate setup as 100 packet per second. Okay. Okay. Now I am going to send a traffic now. Yeah. So Ethernet 1 is my 3x, and Ethernet 3 is my RX. So 100 packet per second, we are not getting any drop in between. So we are getting a full traffic at the rate of 100 packet per second on the other end. So receiver is getting this traffic. Okay. Now we can check the device. Okay. So before going to that, what will happen is, as Prasad told, once the FHR getting a traffic, it will do the PIM registration. Okay, so PIM register, it will be a unicast packet which will reach the RP, right? So at RP, it will do RT7 generation, and it will be given to the replicator. Okay, so once a RP getting a PIM register message, he will do the RT7, and it will be given to the replicator. At replicator, it will do the usual process of reorigination. That is how the RT6 got reoriginated, right? Similarly, this RT7, that is SDOMP route, it will be reoriginated at replicator, and it will be given to the FHR device. Okay, so once the PIM register comes to RP, RT7 generated, and it will be given to our replicator, and then FHR getting the RT7. Then source AD, that is once the FHR getting an RT7 message, he will reply with the RT5. We call it a source AD route, right? Which will be given to all the CHs, not only RP or replicator or LHR. It will be given to all the CHs. I will show each route, okay, each route and what are the next stop and all. But as an overview, I'm telling this. Okay, so FHR will do the RT5 propagation to all the CHs. Then LHR, who is having a *G entry with OF not null, right? That is, we is having some receiver. He will getting this RT5, and then he will reply with the RT7 toward the replicator. Okay, so we anyway, I'm theoretically I told this, but I can tell I can show you how the routes are propagated. Okay, let us start from the RP where first PIM register message has come. Currently, this system is converged because already it has 1 minute or 2 minutes gone, right? So the system is fully converged and the traffic is flowing in the source tree only. But we can check how the routes are propagated now. Okay. Okay, there you go. So here, earlier I showed you the right. I mean RT6 for this 227.0.0.1 has come. Okay, once the traffic start from the device, I mean source, FHR will send a PIM register message, and then once it get the PIM register, this RP will send an RT7 join, that is SDWAN route towards the next stop, that is replicator. Send:1 means it is sending that. Okay. So RT7 is sent by this RP towards the replicator. Now we can go to the replicator. Okay. At replicator, for this 227.0.0.1, I have got a okay, RP is 150. I have got send:0 means it is receiving this. Okay, I have got a SG join, that is RT7 for this 227.0.0.1 group coming from the RP device. Now my thing as a replicator, I need to do the reorigination, and I am doing this. Next stop will be 1.140. So SG join will be reaching the FHR. Send:1 means it is reoriginating that for this 227.0.0.1. Okay. Now we can go to FHR. Okay. RT7. Okay. I am getting an RT7 SG join from the replicator 1.180 send:0. I am receiving this. Okay. As a reply, I need to send an RT5 because I am the FHR. RT5 next stop will be 000, meaning it has to go to all the CHs. Send:1 means it is actually sending this. Okay. So RT5 will be given to all the CHs. Okay. Now we can go to LHR. I will also show the vSmart routes too. Okay. Here, LHR, I am getting an RT5 message from the 1.140, meaning I am getting a RT5 from FHR send:0. So I am receiving this for this group. Then since I have a receiver, right? So in StarG entry, I mean, this is a LHR device and I have got a receiver behind me. So I am going to send a RT7 reply to my replicator, that is 1.180. Okay, send:1. Next stop will be 1.180. This is how the routes are propagated. Maybe I can show you the OMP multicast routes in my replicator device. Yeah, here I am getting a StarG join from 1.60. Okay, towards my 1.180, that is replicator. Okay, then I did the reorigination of this RT6 and I gave the StarG join towards the RP device 1.150. Sorry, 1.50. Okay, then I started the traffic. Okay, FHR, that is 1.140. From 1.140, PIM register goes to 1.50. That is a RP device. Okay, RP reply with the SG join for this group 227.0.0.1. So RP send a SG join towards replicator. At replicator, he will do the reorigination of RT7 1.180 and given to FHR device. Okay, then source CAD route. Once FHR getting an RT7, the SG join, he will send an source active route RT5 to all the CHs 000. Okay, then LHR got an RT5. Then he will reply with the SG message, SG join towards 1.180. This is the actual flow what Prasad showed in the PPT. Okay. Also, we can check the vSmart entries too. So SD-WAN, so OMP, multicast. Yeah.
Just one point to note here, the internal comments that Ganesh told are primarily for driving the understanding. The SD-WAN multicast routes, the OMP multicast routes that are being showed here provides you a much better view or more readable view. And these are the commands that are recommended typically for first level debugging. The internal commands are used for advanced level debugging. Of course, we showed them in the interest of explaining.
I think your voice is breaking a little. Probably.
Oh,
Yeah,
okay.
for me too.
Okay, sorry. What I meant to say, is it audible now or
Still the
what
same.
I meant to say is, okay, I'll put it in the chat window. Not a problem.
Sure. Thank you. Thank you.
Okay, here the vsmart show commands. Okay, sorry. Okay, this is a SD-WAN OMP multicast route for this 227.0.0.1, right? So as Prasad told, vSmart is the one who is something like an IBGP RR kind of role here. Okay, so whatever the join, it will go to the vSmart, and from there only we can enforce policy on behalf of data plane or control plane traffic and all. Okay, so let me go to the OMP multicast route here. Okay, I am LHR device. I am getting a star-G join intended to send that star-G join toward the replicator. Okay, then this replicator 1.180 will this star-G join will be given to the RP device 1.50. Okay, then I start the traffic. FHR will send a PIM register message toward the RP device. Okay, RP is 150, right? So he will reply with the RT7 toward the replicator. So this 1.50 sending an SD join towards the 1.180. Okay, then replicator will do the reorigination of this SD join, that is 1.180 to 1.140 FHR. Okay, now FHR getting a SD join RT7, so he will reply with the RT5 message. Okay, 1.140 to all the CHs. Since it is an FHR, I'm having a source active, so I am sending a source active message to all the CHs. That is how we need to interpret that. Okay, then LHR will get this RT5 message, and then since it is having a receiver behind it, he will reply a SD join, that is sending that 1.60 SD join toward the 1.180 replicator device. Okay, so system is already converged now. Okay, and the traffic is flowing in the source tree only. Let's see how the MFib entries are look like. Okay, how which is the accept interface and the forwarding interface and all. Okay, there you go. So here, this is my FHR for this SG group. I am getting a Harvard forwarding rate. I'm getting a traffic with 100 packet per second. Accept interface will be the one where the source is connected, and then forwarding is toward the LSP BIF interface. Okay, LSP BIF interface, that is SD-WAN cloud interface. Here, LSM ID we have specified. It has come as 2, right? So we will check what is that about. LSM ID 2. Okay, so here the traffic comes to the this gig 002, right? Then it will be forwarded to the LSP BIF interface with LSM2, meaning it will go. We need to check this replication branches here. Here the replication branch is replicator, that is 1.180. So meaning this traffic is going to the replicator now. Okay, let's go to the replicator now. Okay, for this SG, I am getting an 100 packet per second, LSP with 0 interface, and one more thing to note here, flags are both A and F is there, meaning that is a special case I told you, right? So in SD-WAN world, both IAF and OIF are same. So this accept interface and forwarding interface both are same, and it is pointing to the LSP BIF interface. Okay, we can also check the MEP and replication where the traffic is go to the next stop here. Some ID this one. Okay, so here 1.160, this is my LHR. So meaning the traffic is from FHR, it is reaching the replicator. Then replicator, if you check the MEP and replication, it is pointing to the LHR now. Okay, so the traffic is coming from FHR to replicator, then to LHR. Here. Okay, here this MFib and I'm getting an 100 packet per second, and I am getting a traffic from the LSP with interface, SD-WAN cloud interface. So accepting is A flag is set here, and then forwarding is toward the Ixia where we are getting a star G join. Okay, so currently the traffic is flows from source to FHR, replicator, LHR, and receiver. We have already bypassed this shared tree because it's, already we started the traffic almost 5 minutes back, right? So currently it is in source tree only, so we don't need to check any show commands. Traffic is not flowing to RP device. So we saw how the routes are propagated when LHR getting a star G, star G IGMP join. Then we saw how the RT6 goes to replicator, and then from replicator reorigination happened, and it will be given to the RP device. Then we started the multicast traffic from the source. FHR getting a multicast traffic, he will do the PIM registration towards RP. Okay, RP device will do the RT7 propagation, and it will be given to the replicator. And this similarly same thing, replicator will do the reorigination and it will be given to the FHR. Okay, now FHR will once it gets the RT7, he will reply with the RT5, that is a source active route, to all the CHs. That is why we saw next stop as 000, right? So it will be given to all the CHs. Then LHR will also as one of the CH, right? So he will get this RT5, and he is having a receiver behind it. So that is SARG with OAF of some not null value. That is it is having some interface connecting to the XCR, right? So he is telling I am having a receiver. So as a reply to this RT5, I am going to send an RT7, that is SG join towards the replicator now. Okay, this is how the exact flow, and we saw how the MFIB entries are there in each device, FHR, replicator, LHR device. Any doubts? Also, we saw how the replication we need to check. I mean, on which who will be the replicator branch, and I mean the traffic goes to where and all. That is via this command. Okay.
Yeah, thanks, Ganesh. I hope you're done.
Yes, Guru. Thank you.
All right, thank you so much. Team, please raise your questions on Q&A section so that we should be able to assist your questions addressed. Yeah, let's take a 15 minutes break and we will come back in 15 minutes. Okay, I'll just start the timer now. Thank you.
Okay. Guru, can you make me the presenter?
Yes, I am doing it.
Thanks. Thank you. Okay. Hi everyone. Good afternoon. This is Ramchandran. Yeah. So today we will be seeing on device onboarding options and how do we onboard a VH or CH router into the SD-WAN overlay. So yeah. So here we'll be having 3 options for a device onboarded into the SD-WAN network, right? So here the first option is using PNP, which would be PNP or ZTP processor, right? So in general. So the second option is manual option, which is without PNP. Basically, we do put a minimal configurations manually onto the device for the onboarding process. And the third option is to use a single, like I would say it's somewhere in between. So you will have the configs in a USB file, and then we do plug it in on the hardware on the routers, and then boot it up the routers, so it can pick the configs and undo the onboarding process. Okay. So we'll focus on each of these one by one. So onboarding using PNP, right? There are prerequisites on this. So when we do this kind of PNP onboarding, the prerequisites would be all the assumptions is like we should have the DHCP and DNS configured on the or like the IP address on the transport side should get an IP address assigned by our DHCP, because it's going to be a zero touch. So we need to get the IPs on the WAN interface via DHCP. And also DNS should be able to resolve the device helper.cisco.com, which is in the Cisco public cloud. So basically, we assume that, and these are the prerequisites for the PNP option to work, right? So assuming these, let's say we boot up our managed router. So it would try to, as soon as it boots up and all the processes start running, it would start doing a PNP. PNP would kick in and it would start resolving the device helper.cisco.com. And as soon as the DNS resolved, IP is assigned, and the DNS query is resolved, it is going to send a query to the cloud Cisco Cloud PNP server and present its serial number to the PNP server, which is in the cloud, Cisco Cloud, basically. Right. So basically in the internet. And once the serial number is authenticated or validated in the PNP server, it identifies that, okay, so this serial number of this managed router is part of this overlay or this PNP profile. And based on that PNP profile, which we have defined there in the PNP virtual account and smart account, there should be a we should have our controller profile defined, and this the serial number of that particular VANET should be mapped to that particular controller profile as well. Once that is verified and validated, it's going to see the PNP server is going to respond back with the VBond IP or the FQDN and the organization name and the other parameters like root certificate or something if required. If you have, it can send the root certificate as well if it is an enterprise root certificate. Right. Once that is all redirected and sent back from the PNP server to the VANET would receive that and configure that onto the VANET device. Would configure that like it wouldn't be statically configured. It will redirect, or like once it gets those information of the VBond, it is going to query to the send its initiation towards the VBond. So it will try to initiate a channel to the VBond, and that would be a DTLS tunnel. So it would initiate a connection to the VBond, and VBond will verify this again. It would start verifying the serial numbers based on the whitelisting. It would start verifying the serial numbers and the organization name, and as well as the certificates. And the DTLS tunnel will be established. Once the DTLS tunnel is established with VBond, VBond is going to respond back with the vManage information and the vSmart informations to the VANET. And once that is again shared with the from the VBond, those vManage information and the vSmart information is shared by the VBond. Then VANET would initiate the connection with the vManage, and then it would initiate the connection to the vSmart as well. All of these would be DTLS tunnels by default, right? And once the vManage connection is through, it can actually send the full configurations to the SD-WAN router, and based on the configurations, the vSmart can be a DTLS tunnel or it can be a TLS tunnel as well. Once that is once the control connections are established, and the process would be pretty normal, like the manager would be able to establish the routing and the data plane and establish BFT tunnels between site to site, and the traffic can start forward. So this would be the PNP process. The device gets onboarded into the fabric using PNP. Right. This would be a zero-touch process where your device gets onboarded entirely without any interventions on the CLI, at least on human interventions would be required on the CLI. So the only prerequisite for this would be DHCP and the DNS. Okay, let me move on. So in case you might have some scenarios where you don't have the DNS and the DHCP options, where you say, for example, you might have an statically configured IP address on the WAN transports. So in those cases, you may not be able to get the IPs assigned, right? So so in that case, we should go ahead with the or the only option, or like that's one of the option for going with non-PNP option would be we need to configure some or basic manually configure some of the basic parameters like system IP, site ID, organization names, and the interface parameters like color, transports, encapsulation, the default route, IP address. These are the stuffs which the basic interface parameters and the mandatory or minimum basic configurations required for establishing the control connections with the controllers. So these are required to be enabled manually on the device for manual onboarding process. We will see this in a short while. We will see the detailed steps and what are the minimum commands required. We'll be seeing that. Once these configs are done, again, the process would be similar. The reachability to the vBond is required. Basically, once we do the minimal configuration of interface and the default routing is taken care. And if it is going to be an FQDN, then the host entry might be required, or a DNS can be configured. So basically, both options can be done. Once the reachability is done, the communication will be the same as similar to the default PNP process as well. So, but we'll have to set up the minimal base configs for the SD-WAN overlay to come up. Right. So in this process, any SD-WAN router boots up, right? In a fresh SD-WAN router with no configs is there, it boots up with the software. It would a PNP process would be by default started, and the discovery will be on, right? So it will be it will try to start the PNP process so that it will try to reach to the PNP server. And in our case, the PNP server may not be reachable because there would not be an DHCP. IP cannot be assigned via DHCP and stuff because of the networks, basically because of the network status, and there is no DHCP server available on the transport. Right. So in this case, as soon as we log into the router, we cannot do any configuration until unless we stop the PNP process. Discovery process will be stopped. We cannot do the router would not be allowing us to do config transactions, like would not allow to configure anything, right? So for that, we'll have to stop the PNP service discovery. Like PNP service discovery stop is a command. So we'll have to run that command to stop the PNP discovery first. Once it is stopped, we'll get the access to do the configuration and enter into the configuration mode using the config transaction command. And then once we enter into the config transaction into the config mode, we'll have to configure the base parameters like system IP, which is one of the base parameters which the vManage and the enter fabric and identifies that device with the system IP. Right, and also a site ID is required. So that site ID is one of the parameters which the SD-WAN fabric identifies the device in the policies, and everything can be applied using the site ID. Then comes your vBond under the system configuration mode itself, configuration system. We'll have to configure vBond, where is the vBond server, then the FQDN can be configured or the IP address can be configured, right? So if we are configuring IP address, then the vBond, the device would try to reach out to the IP address directly, vBond IP. If it is going to be a DNS entry, then you'll have to configure the DNS specific configuration as well, which we'll see in the next slide, right? And then the organization name to identify the routers, the SD-WAN router can be identified, and the certificate validations will happen by the when the details tunnels are coming up with the or the router tries to reach out to the vBond and the other controllers. The organization name would be one of the parameters which it authenticates and validates. So we need to have the organization name across the SD-WAN fabric to be the same. Right. And then once this is done, we need to configure the interface parameters. Say, for example, in this case, we have a interface in gigabit Ethernet 001. In that case, we'll have to configure the tunnel number as 1, which is like 001 gets converted to tunnel 1. So if it is going to be 000, then the tunnel number would be 0. If it is 2, then we configure it as 2. And if the interface is, say, for example, gig 010, then the tunnel interface would be 10. Right? This is anyway temporary. If the number varies, you can configure any tunnel number. But if the tunnel number varies, once your vManage is up, the tunnel to the vManage is up, and the config is pushed from the vManage, it will get overwritten, and the new tunnel will be configured, and the old tunnel will be removed. During this phase, your control connections would flap and come back again. So that would be one thing to note. If we have the tunnel number same, so we will not have a tunnel flap as well. It's nothing to worry. Just a tunnel flap will happen because of the config change, right? So when you create the tunnel interface, you'll have to configure the IP unnumbered and map it with the physical interface, physical transport interface, and the tunnel source will be again the same WAN transport, which will be gig 000, for example, and the tunnel mode will be SD-WAN. So these parameters has to be configured under the tunnel, create the tunnel, then we configure the interface parameters, say on the IP address, and unshut that interface. Right? Then we go into the SD-WAN. Under SD-WAN, we'll have to enable that WAN interface with the tunnel and select the color, and then we configure the encapsulation mode as IPsec. We'll have to enable this as well, so that if the tunnel is not enabled under SD-WAN, no DTLS connections would come up, or it been initiated from the WAN SD-WAN router. So we'll have to enable this under the SD-WAN as well. And then for the routing purpose, we'll have to we can add a default route pointing to the next hop of the WAN interface. Okay. Then in case you are having you're getting converting your existing router configs, please make sure you have your IP domain lookup enabled. Right? And if it is going to be DNS based, FQDN is going to be DNS based. The vBond FQDN is configured with the name. Then in that case, you'll have to do this for the domain lookup to happen, right? And then the name server, which is the DNS server IP, we'll have to configure the so towards the DNS server, say, which resolves the host name of the vBond entity. The other option for here is like you can instead of DNS servers, you can configure your manual entry of like IP host command also can be used. So you don't have to configure the DNS server itself. Like if it is you can do a manual mapping also is possible. And if that is all done, we can commit and quit. Once this is done, the managed router would initiate the connection to the vBond, start initiating or looking up for the vBond. The DNS query happens. Then this solves the DNS for the FQDN of the vBond entry. Then the communication starts with the vBond. And after that, it will all be the same. So basically, it tries to reach to vBond once details turn is formed. After the validations of the certificates and the organization names, etc. Once that is all verified, it can reach out to the vManage and vSpot as shared by the vBond. Okay. Yeah, so there's one more point. In case you need to have your if you are using an enterprise certificate, you'll have to on top of these steps configurations, you'll have to add your enterprise root certificate chain also onto the router and install that. Right. So you'll have to copy the root certificate to the boot flash, and you can install the enterprise root certificate using this command: request platform software SD-WAN install and the path, boot flash and the certificate name. So you can install using this. Once this is installed, then the certificate validation also goes through if you are using your enterprise root certificate, like if you are using enterprise root chain for that purpose. Once this is done, the control connection would get established with the controllers. And once vManage's connection is through, the config would get pushed from the vManage to the device, and it can be managed from the vManage. As soon as the control connections are established with vManage, you can either keep it in CLI or move it to vManage mode, like as a standard process. And the third option is to use bootstrap mode, which say for example the base configs, whatever we discussed right now, right? Say under the system you'll have to configure the host name. Oh no, host name is not mandatory. System IP, site ID, organization name, and your vBond entry, and IP address and the default route. So these are the parameters, base parameters, which would be required, and all you can create more configurations also, and generate a bootstrap config from the vManage, and plug that, copy that file to your USB and plug it into the USB of the USB drive onto the router. Then boot the router. It would pick that file and boot from that configs. So we'll see how that is being done. First thing is the USB boot or the bootstrapping process is supported only on the iOS XE SD-WAN images. VHG does not support that, bootstrapping actually. And DHCP, say for example, where you will need this is like in any sites where you don't have DHCP is not possible, say for example in an MPLS network where you have static IP addresses, right? And similar to the manual method, but you may not have someone to do the manual configurations, and the manual configurations you will need control access, right? So in case you don't have control access, you can go for the bootstrapping mode. So, so you can have the bootstrap config on the USB drive, flash drive, and plug it onto the router, boot the router would pick it up and then boot from that config file. And the configs which we did manually will all be there on the USB file. They picked up the configs from the USB file, and it would follow the routing part, and everything would be there. So it then initiate the connection to the vBond, right? Say the workflow in this case is very simple. Like we have to generate the configuration file from the vManage. We'll see how do we do that in a minute. And then once the configuration file is generated from the vManage, you can actually copy that to the USB file and connect it to the router and power on the device. That's it, right? So let's see how do we get this bootstrap file generated. Say for example, you have to have a template attached to that particular device, whichever hardware you want to use the bootstrap method. You have to attach a template, and the device would be in scheduled mode once you attach it, right? So once you have that device already attached to a template and the configs are the variables are all attached to that, say it will be in scheduled mode when you do that. And actually when that is done in scheduled mode, you can go to the managed list here in the vManage, and click on the three dots and do a generate bootstrap configuration. And then once you do click on generate bootstrap configuration, a file will be downloaded. It will ask you, you want a cloud init file or encoded string. Select the cloud init option. Once you select the cloud init option and click OK, the file will be downloaded into your local machine. Say yeah, you can click on the download. Basically click on the download, and this is the config which will be generated on the bootstrap file. Click on download, save it to your local disk, and you'll get that file. The file name will have the serial number of the device. Like this is a cloud device, so you see a bigger chassis ID basically. But in hardware devices, you'll see like say for example ASR 1001 HX followed by the serial number of the router. So .cfg would be the file format. So this file will have all your like UID or the OTPs, and in case of software devices, you'll see the OTP and the other configurations which we have done through the entire configuration would remain on the CFG file. Okay. So only thing is like you when you download the file name will be unique because it will be mapped along with the UUID or the hardware serial number, model number, and the hardware serial number. So, but in when you upload this to a or like the file is copied onto the USB serial number, so the file name has to be should be the same. Like say for example, it is like for hardware device models, you should have this file name renamed to Cisco SD-WAN.cfg. And say for example, ASR 1002X model, you'll have to change it to Cisco SD-WAN underscore cloud underscore init.cfg. So these are the standard names which the router, when it boots up these CFG files, with these names alone, it will look up, not based on the serial number or anything. It will look up exactly for these serial the file names to be there on the USB or on the boot flash. So basically, the file name, if the file name matches, that is when the router will pick up the config. So make sure before copying to the USB, you have the right configs with the file name changed to Cisco SD-WAN.cfg for the hardware platform. Similarly for the ASR 1002X model as well. Okay. Once you have that changed and copied to the boot flash, or you have it on your USB, plug the USB onto the router and then boot the router. So the router can pick up the file which has a config, and the file name should be Cisco SD-WAN.cfg or the Cisco SD-WAN cloud init.cfg, and based on the hardware model or the kind of stuff. So once that is confirmed, the config is pushed. Meaning once the file is identified by the router while during the boot up, so the router can pick up the So basically, the router will pick up the configs from that storage, and it'll copy that file to its running config and store it in the. It'll also copy and commit actually. Once the file is committed, it'll automatically pick it the configs and save it. Then it will start initiating the communication with the vPoint along with the entire running configs basically. Right. So while doing this, you will have to keep the router powered off, and after you plug the USB, after that only you'll have to boot the router if in case the router is already on. Right. Yeah. After that, the normal PNP process starts, and it can reach out to the PNP server, or it can, based on your configs, it will reach out to the vPoint directly. Yeah, that's it. On my side. Hey, Guru.
All right. Yes, Ram.
Thank you.
Thank you so much, Ram.
Thank you.
Maybe if you have any questions, please feel free to raise it on your Q&A section. Ram, please try to address that.
Sure.
Thank you. I think we'll move to SDRA. Probably I'll hand it off to Amjad for the present. This is a bonus session which is going to come in the next release. Okay. Amjad, over to you. Thank you.
Yeah, thank you. Thanks, Guru.
I'm making you presenter now.
Sure. Yeah, let me share the slides. Are the slides visible?
Yes, Amjad. You're good.
Okay. Yeah. Hello, everybody. Good morning. Good afternoon. Welcome to the SD-WAN integrated remote access presentation. I'm from the enterprise routing engineering team. I also have with me Anup, who will be answering your questions on the chat if you have any questions on this. So as the name suggests, SD-WAN integrated remote access, which we refer to as SDRA, it fully integrates remote access into SD-WAN network. And it enables two important use cases. One is it enables SD-WAN for hybrid work, and it also enables SD-WAN last mile, which allows for large-scale SD-WAN deployment, especially with thin branches like ATMs or gas stations. So what is the problem we are trying to solve? If we look at the trend of the percentage of remote access traffic, the RA traffic has really spiked up during the pandemic, and it'll remain so with the new hybrid work model. So traditionally, remote access traffic used to be a very relatively smaller percentage of the overall enterprise traffic, right? But and then the remote access infrastructure also was deployed to handle or to cater to this relatively smaller percentage of the overall traffic. So the infra also was proportionate to that. But now with the pandemic, all the remote access, all the traffic suddenly became remote access traffic, right? And there were two implications of that. One, when a customer deploys SD-WAN at different sites, branches, hubs, data center, the WAN capacity and the router capacity, the router platform that is deployed, and the amount of WAN bandwidth that is purchased from the WAN providers is based on the number of users or the amount of traffic, the volume of traffic that site needs to handle, right? So there is because the number of branches are large, there is a large investment that goes in the the device deployment as well as the WAN capacity deployment. And then for remote access, because it used to be a smaller percentage of the overall traffic, the remote access headends were commonly deployed at some centralized locations. For example, if we look at our own remote access deployment by Cisco IT, for India side, it's mainly the Bangalore cluster that we have for the entire India side, and then we have clusters in other regions as well. So though it's a little distributed, but over larger areas, it's a little centralized. So what happened with as during the pandemic situation was everybody started working remotely, which means there were two implications of that. One is the remote access infrastructure, which was centrally deployed, it was stressed because it was not deployed to handle that kind of capacity, right? So which resulted in overutilization of the remote access infrastructure, leading to lower quality of experience, right? On the other side, the the infrastructure that was deployed at the branches, the investment that was made at the branches at various other sites was lying idle. The WAN capacity, the router capacity, because there was nobody working from offices, all that infrastructure was lying idle. So on one side, there was unused infrastructure. On the other side, there was an infrastructure which was getting stressed a lot, right? Now, which means the whole remote access architecture needs to be rethought, re-architected, and redesigned, given the current situation and the given that the hybrid work would be the future of work. And then we also need to ensure that when this remote access traffic becomes the mainstream traffic of the enterprise, we ensure that the user gets a consistent user experience in terms of the similar quality of experience as if the user is working on-prem versus remotely. User should be able to access all the applications that he was able to access when he was sitting on site. For example, user should be able to access SaaS applications, internet, IaaS applications, as well as on-prem applications with remote access with the same level of application quality. The other is service agility. A very important point. We'll see some of the shortcomings of the way traditional remote access is deployed is typically user uses internet connection to access the corporate resources over long haul, right, which would result in application quality issues. So users should be able to basically remote access infrastructure, we should be able to deploy it at different locations in a distributed manner to be able to handle the capacity. And it should be elastic as well. I mean, as the remote access traffic increases, we should be able to increase the capacity of the infrastructure while providing the enterprise grade security to the users, as if the users were working on site, as well as manageability, right? With ideally, it should all, whether it is remote access or on site, it should all be managed with the single pane of glass. So these are the high level requirements for remote access in the current use cases. So this diagram shows a typical remote access deployment. So we see a site-to-site network. Let's say we have a data center in US region, regional hub in APAC region, and the branches in the APAC region, and they're all, let's say, they're connected over SD-WAN or any other site-to-site network. If a customer needs to deploy remote access, customer needs to deploy additional appliances at centralized, typically deployed at centralized locations. And then a site-to-site network would have its own management station, and then the remote access would have its own management entity, right? So these networks currently are deployed and managed separately, independently. These are considered independent networks with their own management entities, with their own devices, with their own security measures, and which adds to operational complexity and cost. And then we saw that most of the users, remote access users, typically rely on internet connection. And for example, let's say a user in India is trying to access some applications in US data center, and the user is trying to access it over a single internet connection, right? So this could impact application quality of experience, because when a user is sitting at a branch, on-prem, so user has the choice of business grade WAN links like MPLS links or lease lines and all of that, and user has the benefit of getting application visibility. He can leverage app SLA routing, WAN optimization techniques like app QoE, and then user gets the enterprise grade security like zone-based firewall, UTD, NATDI, etc. So all the SD-WAN goodness is typically limited to site, or for users sitting on-prem, not for remote access. And this would result in application quality of experience issues. Now, some of the possible solutions that come to mind to solve this problem is, one would ask, okay, why can't we have SD-WAN stack on the end host itself, on the laptops, for example? But then the challenge with that is there are multiple operating systems that we'd have to deal with: Windows, Mac, on handheld devices. Implementation and sustenance cost and complexity would be huge with this kind of model. The other possibility is, why not deploy a small device, small SD-WAN branch at every user's home? Now this, in this case, the SD-WAN is typically, or site-to-site networks are designed to scale to the number of sites, not to the number of users. Because if each user becomes an SD-WAN site, it would result in very high scale site-to-site network, and it can get too expensive. So then the answer, one of the solutions or the proposed solution, is the SD-WAN integrated remote access. And the idea here is to leverage the SD-WAN fabric itself as the remote access termination point, remote access entry point. So leverage SD-WAN fabric as an RA entry point, where we not only leverage the management station, it's not just at the management level, it is also at the device level. So the same SD-WAN edge device that is used for SD-WAN termination can now terminate remote access users. And the same management station we manage, which is used to manage SD-WAN site-to-site, will be able to manage remote access as well. So that is the idea. And one of the questions would be, how is this possible? Now, this is possible because many of you would know that iOS XE routers we traditionally support a very feature-rich remote access VPN functionality, in addition to site-to-site VPNs like GetVPN, DMVPN. So Flex VPN is V2 IPsec-based remote access VPN, as well as SSL-based VPN. It's widely deployed by customers, both by enterprise and MSP customers. It's very scalable and feature-rich. Now, iOS XE SD-WAN devices inherit this Flex VPN stack. On one side, it has the Viptela stack, and it also has this remote access stack, now which allows it to terminate the remote access connections. If you look at any other remote access solution, it'll typically be a two-box solution, maybe with a single management station. But in this case, it's integrated at the device level as well. So the idea is to terminate the remote access connections to the closest branch. And then once the user terminates at a branch, the RA user virtually becomes like a LAN side user. And he'll be able to benefit all the SD-WAN goodness in terms of all the SD-WAN features that are available for enterprise traffic as well as DR traffic. User will be able to access SaaS applications and benefit from fast connect to the SaaS clouds. He'll be able to access on-prem applications using SD-WAN app-aware routing, app SLA routing, IaaS applications, again using app visibility, app-aware routing, etc. And the user will be able to break out to the internet. It can be through cloud web security, or it can use the local security that is there on the device. So the whole idea is to get user onto SD-WAN as quickly as possible. Right. So let's say a set of users who work from a branch, a smaller branch in some city during normal hours, when they during off hours, when they connect from home, they'll be connecting to the nearest branch, the same branch. So which means the same set of devices and the WAN capacity that they have will get utilized to serve the same set of users, and the users get virtually the same experience as if as they were getting when they were working on-prem, in terms of access to different kinds of applications, in terms of all the SD-WAN benefits. And like I mentioned, all of this would be managed from vManage. There would not be any separate management station. vManage would be able to manage the remote access head-end functionality that is integrated into the SD-WAN edge devices. Now, let's take a quick look at the iOS XE remote access VPN, which we refer to as Flex VPN. And so this Flex VPN we support both IPsec as well as SSL. We support Cisco and third-party remote access clients, both software clients as well as hardware clients. Software clients like Cisco AnyConnect, or we also support OS native clients like Microsoft Windows, Mac OS, as well as hardware clients, which can be used as thin branches, SOHO routers. And then FlexVPN has full integration with Radius for authentication, authorization, and accounting. There is full integration with PKI for certificate management. And then for routing over remote access VPN, I mean, we support very simple static route, automatic static routes over the VPN tunnel. You don't really have to run dynamic routing protocol or use manual static routes. If needed, dynamic routing is also possible with SOHO devices. In terms of scale, just to give an idea, a single ASR 1K supports roughly around 8,000 to 10K sessions, remote access sessions. And we also support redundancy at the link level, head-end level, and horizontal scaling. We can, like as shown in this diagram, we can create a cluster, let's say at a given SD-WAN site. We have multiple SD-WAN edge devices. They can form a cluster and load balance or do horizontal scaling of the remote access connections. Plus, the FlexVPN supports dual stack, both at the underlay as well as overlay level, both V4 and V6 at the overlay and underlay level. And there are a lot of other features that are supported. Now, all of this is inherited by iOS XE SD-WAN device. Now, just to give an idea, this is the list of remote access clients that is supported by FlexVPN and now SDRA. AnyConnect, Windows clients, the SOHO client, hardware client, Strong SWAN, and Apple clients as well. Now, some of the benefits of SDRA, the value proposition. Now, with SDRA, we're not coming up with a new remote access solution. Now, this is based on Cisco's proven FlexVPN remote access solution, which is widely deployed both by enterprise and MSP customers. It's very feature-rich, scalable, as well as it's quite flexible in terms of the support for different kinds of clients, support on different platforms, as well as support for different modes like IPsec and SSL. It's a single fully integrated SD-WAN and remote access fabric. And it's a true integration because, like I said, it's not just at the management level, it's at the device level as well. So we completely leverage SD-WAN fabric for remote access with a single management station, single device. Now, it's a one-box solution. Like any other remote access solution that you might see would be a two-box solution where you terminate remote access on one device, and then you forward traffic to SD-WAN device. But then the problem with that kind of approach would be, or the benefit of this single box solution approach is, when a remote access user terminates on a device, the identity of the RA user is, first the RA user is authenticated, and the authenticated identity is translated into policy. An example of that is, let's say, a user who was working on-prem, right? When he onboards using .1x, for example, he gets his policy from ICE, and ICE says, okay, this user belongs to engineering, put him in engineering segment, which could be VLAN, which could be VRF. Now, when the user works from home and he connects over this IPsec tunnel, after his authentication, the identity is again sent to ICE, which could be anywhere on the SD-WAN network. And the ICE says, okay, he's an engineering user, place him in the engineering VPN. So, and the user would be dynamically placed in the engineering VRF, and he can be assigned SGD tags and a lot of other policies as well. So the translation from identity, authenticated identity, to policy happens immediately on the same box. Now imagine if we were to do it using two-box solution, where you're terminating remote access on one box, right? And then I said, okay, place this user in VRF1. Now first of all, your RA termination device needs to support VRF. And when you send traffic to the SD-WAN device, you'll have to communicate this information saying, okay, place this user in this VRF, give him this SGT, give him this policy. So basically, the ID to policy translation becomes a little cumbersome. You need to do additional work, and sometimes it might be difficult to implement as well. So SDRA has minimal impact on SD-WAN scale because, like I said earlier, the RA user, once he connects onto the nearest SD-WAN branch or hub or any C edge, which could be branch, hub platform, it could be deployed in public cloud or colo, any C edge can be used for remote access termination. So once the RA user terminates, the connection terminates there, the RA user becomes a LAN user virtually. So RA becomes like LAN extension. You can virtually think that this RA user is a LAN side user, and he'll be able to benefit from all the features of SD-WAN. Plus, without consuming the SD-WAN scale, the user does not have to connect to vSmart. He does not have to create BFT or IPsec tunnels to any other SD-WAN edge devices. And this allows for a large scale distributed remote access deployment. In cloud-based remote access, typically the POPs would be limited to some geographies. No, you may not, it may not be feasible to have these POPs everywhere, but with SDRA, let's say a customer has an existing SD-WAN network and he has presence in multiple locations. Now, those as branches or headends or hubs can be leveraged as remote access termination points, SDRA headends. And let's say there is a case where a customer has users in some country, but they do not have an office. They do not have edge devices. They can spin up a C8 kV in AWS or Azure in a public cloud or colo and use it for RA termination. So basically extending the SD-WAN fabric as close to the user as possible so that we onboard the user to the fabric as quickly as possible and give him the same policy and quality of experience. It's zero trust and it's authenticated identity based policy. Like we said, the first step that happens when a user connects is authentication. And with with clients like AnyConnect, we support posture validation, etc. So user is first authenticated. It's a zero trust policy, and after that, the authenticated ID is used to provide policy from the common ICE that is deployed in the network that is used whether the user is on-prem or in remote access. Allows for unified policy. And another very important benefit of this solution is that the remote access traffic remains within the enterprise fabric. Let's say a customer has, let's say it's a financial customer who do not use public cloud for anything. But for cloud-based remote access solutions, the traffic would have to terminate in cloud, in third-party cloud, and the traffic would get decrypted in that cloud. But with this solution, the traffic still remains within the enterprise fabric. The traffic is getting decrypted on the SD-WAN edge devices. So the traffic remains within enterprise control. And all the users, all the benefits of SD-WAN would be available to RA users: app visibility, SLA path, best path, AppKO, UTD, all the features. It's the RA user is like a LAN side user. And this also allows for large-scale SD-WAN deployment when the remote access client is a thin router, IOSXE device. Because this device just needs an IPsec tunnel to the closest branch. We'll talk about this use case in subsequent slides. And this smaller branch does not really have to connect to vSmart or create BFD tunnels. So this allows for a large-scale deployment wherever we have the need for thin branches. And all of this, SDRA is transparent to remote access clients. There's absolutely no change needed to RA clients. RA clients don't care whether they are connecting to a traditional RA headend or the SDRA headend. And it also allows for rate limiting of traffic. Now, one might say that, okay, we have this SD-WAN edge device. It was meant for LAN traffic. Now, what if we terminate remote access traffic? Will it be able to handle that capacity? Right? And what if the RA user tries to consume the entire WAN capacity? So there are mechanisms available where, let's say, if a router supports 2 gig of throughput, and you want to set aside only 500 Mbps for RA users, both upstream and downstream, it is possible using cost policies and policers. So you can set aside the amount of throughput or capacity that you want to use for RA users and the remaining bandwidth for the LAN users. Like we said, this SDRA enables two main use cases. One is SD-WAN for hybrid work, which is enabled by IOSXE SD-WAN and ICE. So in this slide, we have, let's say, a campus, which could be SDA or non-SDA campus. On the other side, we have, let's say, an SD-WAN hub or a branch connected over SD-WAN fabric. And most of the enterprises would have Cisco ICE deployed, which are configured with per user a group policy. And let's say a user onboards onto a branch using .1x. So based on his authentication credentials, policy lookup happens, and an example of that policy is which VRF to place that user in, which LAN segment, and what SGD to assign, which could signify which project he's a part of. And in addition to that, because he's connected to an SD-WAN fabric, the user gets app visibility. We'll be able to see all the applications that the user is using, app SLA routing, app QoE, and all other features. Now, let's say when the same users works from home, and when this user connects to the branch, closest SD-WAN branch or hub, as the customer decides, the user's identity is used for policy lookup, and the ICE gives exactly the same policy. The VRF engineering and then the same SGD tag, and the user's tunnel, when the user connects, that user's tunnels is placed in the corresponding VRF, and he's assigned the same SGD tag. So the same treatment from an SD-WAN edge perspective, there's no difference whether the user is on-prem or he's connecting over remote access. He'll be placed dynamically in the required VRF based on his identity. And if you need to place the user in different VRF, all we need to change is the ICE policy. And then once the user connects, the user gets all the same features. So it's a unified fabric, unified policy, and unified experience for site-to-site as well as remote access traffic. It's zero trust because it's based on dual factor or multi-factor authentication, identity-based user policy, and application experience remain consistent. The other use case that is enabled by SDRA, just check the time. Yeah, another use case that's enabled by SDRA is large-scale SD-WAN deployment with thin branches. So this diagram shows an SD-WAN deployment where we have a campus and or hub and branches connected over SD-WAN fabric. And then let's say there are some thin branches like ATMs or gas stations. Now these thin branches, they don't have to be full-fledged SD-WAN branches, because the moment you make it a full-fledged SD-WAN branch, it'll connect to vManage, it'll connect to multiple vSmarts that you might have in the network, and each of this uses an independent TLS-DTLS connection with its own keep alives, and then you'll have to do a BFD session with the hub. So basically, the amount of traffic that you need for the base, the minimum traffic that you need, the minimum traffic requirement increases. I mean, in addition to data traffic, just to bring up that branch, you'll have some minimum traffic requirements. Plus, it'll have an impact on the SD-WAN scale in terms of the number of connections that your controllers need to support. Now, the idea here is to leverage the SD-WAN branch or hub as satellite hub, and then use, at the thin branches, use SOHO devices, which could be iOS XE devices, which we refer to as satellite branches here. And the connection between the satellite hub and satellite branch is what we refer to as SD-WAN last mile, which is much lighter than the actual SD-WAN. So in this case, the connectivity between the SOHO and the satellite hub or SD-WAN edge can be over internet or private WAN, and the connectivity would just be over IK-IPsec. So all you would need is IK-IPsec, standard IK-IPsec connection, and the only set of keep alives that you'll be running is IK keep alives, which you can slow down as well. And you would not need to run any routing, etc., because typically the thin branches have a single WAN link, like VSAT or lease line, or like ATMs. They do not have multiple WAN links. So you anyway would not be able to benefit from many of the SD-WAN features like link selection, etc. So this sort of minimizes the requirements that you have to connect your thin branches to SD-WAN fabric. And some of the benefits is all you would need is standard IK-IPsec connections to the nearest hub or branch. And it can be in an active backup fashion. For example, let's say a branch hub has multiple SD-WAN edge devices. You can configure your SOHO devices to connect to the first one. And if it does not connect, then try the other one. And this primary backup can be at the same site or at different sites. It uses lightweight automatic static routing. The question is, how would routing happen between the satellite hub or SD-WAN edge and the thin branch? So like I said, we use automatic programmatic static routing between the SD-WAN edge and the SOHO devices. Both the sides just have to advertise what subnets they have, and the routes will automatically be added. So there's no need for a separate routing protocol and routing protocol hellos. And then there are very lightweight IQ2 keep alives, which you can tune based on the requirement. You can slow it down. Just one set of keep alives. There's no need for separate keep alives for control and data connections. That's why there's less impact on SD-WAN control and data plane scale, because the SOHO devices don't need to connect to your vSmarts as well as to the other SD-WAN edge devices. And the SOHO devices, by the way, they can be assigned to different LAN segments. When they connect to the hub or branch, they can be placed in different LAN segments based on their identity. We can also split tunnel directly from the SOHO devices if needed, and there is also support for dual stack. But this allows for integration of iOS or ISXE devices into SD-WAN in a phased manner. I mean, if customer has iOS XE devices, I mean, one use case is customer has thin branches, the greenfield deployment with ATMs or gas stations can use this model. Or let's say there are cases where customer already has iOS or ISXE devices, they can be integrated into SD-WAN without converting them into a full-fledged SD-WAN branch. And then in a phased manner, they can slowly be converted into SD-WAN branches. Yeah, so currently the SOHO devices can be onboarded manually, but then we are looking at ways to manage the SOHO devices as well from vManage. That should be possible as well. So both the SD-WAN satellite hub and the branches can be managed from vManage. Though the SOHO devices will not connect to vSmart, they can still connect to vManage and be managed from vManage. Yeah, so some of the deployment considerations for SDRA is, of course, the capacity planning, because for SOHO devices or software-based clients, we use IPsec connections to terminate into the SD-WAN edge, and the same crypto engine on the platform gets used. Same crypto engine, the WAN bandwidth, and the router throughput gets shared by the SD-WAN IPsec tunnels and the remote access IPsec tunnels. But then we have a way, like we said, we can very clearly control how many RA tunnels we want to support and how many RA throughput we want to support on that device. We can clearly set aside that many number of tunnels and the throughput capacity. But then a key point to note is that both SD-WAN IPsec and the remote access IPsec share the same set of resources. The other one is if the connectivity between the RA client and the headend, which in most of the cases would be internet, in that case, RA headend needs to have a static public IP. But then if it's a SOHO router, let's say ATMs or gas stations where there is private WAN connectivity, there's no need for static public IP. And in case of, let's say, any connect client, which mainly uses EAP kind of authentication, the headend needs a certificate. So you need to have some sort of certificate management. But then for SOHO, it might be optional where customers might use pre-shared keys. And again, the private IP address pools for assignment to the remote access clients, like any traditional remote access. And this again is optional for SOHO. Now, this diagram just depicts that the RA user, when the RA user connects to an SD-WAN branch or a hub, basically we create a virtual interface per user, and that virtual IPsec interface is placed in the appropriate LAN segment based on the user identity. And once the RA user connects and sends traffic, after the traffic gets decrypted on that IPsec interface, after decryption, the RA user might be trying to access the LAN side resources at that branch, or he might be trying to access internet, where the traffic will happen and go to the internet, or the traffic might happen and take the SD-WAN tunnel to access resources at the data center. For all of these, the traffic coming out of the IPsec interface after the IPsec tunnel terminates is treated as the LAN side traffic. So you'll be able to apply data policy, you'll be able to apply all the policies that you normally apply for traffic coming from SD-WAN LAN segment. Yeah, this slide depicts that your SD-WAN SDRA headend could be a regional hub. It could be an SD-WAN edge deployed in a colo location, or it could be in cloud like AWS, Azure, etc. In phase 1, we are supporting RA termination mainly on the hub platforms like 8500 and ASR1Ks and C8KV in public cloud. We'll add support for branches in the upcoming phases. And in terms of the solution readiness, the solution is getting released in 17.7, but then the configuration of the RA headend functionality on the SD-WAN edge would be using CLI Aron templates. And the RA client monitoring, again, would be through the show commands on the device. And then in phase 1, we support any connect in the IPsec mode and the enterprise CA server. In phase 2, we plan to add support for vManage UI. Basically, we'll have feature template to configure the SDRA as well as separate monitoring screen for SDRA. And we can leverage vManage as a CA server for the RA certificate management. We're also planning to bring in the DO integration as well as SSL VPN in the upcoming phases. Yeah. So just to give an idea, in this diagram, what we have in a small demo setup is these are two non-SD-WAN branches, Soho branches, green and blue. And then we have this SD-WAN branch acting as the SDRA headend, and then we have data center connected to this SD-WAN RA headend over SD-WAN fabric. When the user connects over an IPsec tunnel to the SD-WAN edge, at this point we don't know which VPN to place the user in. So once the user connects, as part of authentication, the SD-WAN edge can reach out to ICE or radius server that can be deployed at the data center in a common VPN. So after authentication authorization, ICE or radius server tells which VPN to place the user in, and then the IPsec tunnel will be created in that VPN. And the traffic from that user takes that VPN tunnel and it can access the resources only in that VPN. And similarly, the user will be able to access the DR traffic as well, in addition to the enterprise traffic. Yeah, so that's all I had. This was a quick overview of SD-WAN integrated remote access and what are the use cases it tries to address. Please feel free to reach out to us in case you have any questions or if you want to try it out, both with software clients as well as with hardware clients. Thank you.
Thank you, Amjad. Thanks for the session. And please feel free to raise any questions on the Q&A session so that Amjad and team will be able to assist. All right, we'll go to the next one, probably the SD-WAN roadmap, committed roadmap. Ajay from the product management team is going to take over. Ajay, over to you. I'm going to make you presenter.
Thanks, Guru. Hi, everyone. Good morning, good afternoon. Let me share. Hope you can see the screen.
Yes, Ajay, go ahead.
So we are going to walk through SD-WAN roadmap for the Viptela solution, and I'm going to cover from the releases 20.6.17.6 to 20.8.17.8. I am in the enterprise routing / SD-WAN group based out of Bangalore. So just a disclaimer that some of this is of course released already and some of this will be released in a week or so. But beyond that, something like 17.8 or 17.9, I mean, it might change a little bit based on, various factors like COVID and, other things. So just for that. So let's start with our strategy. I'm sure you have gone through very technical rich sessions over the last few days. Just wanted to take a step back and, think about what we are trying to do here as in the whole solution, right? At a basic level, we are trying to provide you tools to connect, to secure, and to automate your networks, right? Now, when we say connect, it can be any kind of transport from your MPLS to your internet to 5G to even the emerging software-defined cloud interconnect, right? So all of those transports can be used to connect your regular branches or even the, what Amjad touched upon, where you want to connect your teleworkers to your SD-WAN network, right? So that is one of the pillars of our strategy. Of course, security is a big play in our strategy. We are one of the few companies who offer you the whole stack, be it on-prem security or be it cloud security in terms of umbrella. The SD-WAN solution is natively integrated to provide you best of both worlds of security as per your needs. And finally, provide you all of these features in terms of connectivity or security in an easy to consume fashion through automation, through APIs, or through UI workflows. So that is the philosophy Cisco SD-WAN solution is going towards. Now, we of course know how the WAN connectivity was in previous world and how SD-WAN changed it. Basically, SD-WAN aggregated all different types of transports that you had and provide you a single management pane to configure all your policies, be it connectivity, be it security, be it connectivity towards the cloud applications or to private applications, right? So that was the whole promise of SD-WAN, and with Cisco SD-WAN, we are taking it one step further, where we are innovating with various other aspects that are emerging, the other evolutions that are happening in WAN networks. Now when we talk about trends that we are seeing, so of course all of us are experiencing these trends firsthand, and Amjad again touched upon this, the remote worker trend that we have, right? So he had some statistics from Deloro, if I'm not wrong. And again, we expect that most of the workers, at least half of the workers, would continue to remain remote worker even beyond 2021, right? Now, beyond remote workers, we have trends towards SaaS applications, trend towards cloud. So we can see ourselves, right? How many of us use Office 365? How many of us use cloud storage solutions? So that is something which is not going away. It is only going to increase, right? Similarly, when we talk about using cloud workloads, right? When we talk about instantiating our gateways inside the cloud, right? That is something which is just going to increase, right? So more and more people are going to move towards cloud in terms of their application workloads. So Cisco's SD-WAN is well placed to embrace all these trends, right? When we start with Cisco umbrella, we have one of the best in the industry to offer you security, and not only security, it has direct peering relationship with many of the SaaS providers to provide you security along with very fast connectivity based on the direct peering relationship, right? And then when we talk about IaaS providers like the big three, we were the first to have working integrations with all of these cloud service providers. We had our gateways in their IaaS solutions. We could use their backbone and connect our on-prem branches to something running in their cloud workloads. So all that was done through Cisco Cloud Hubs or C8 KVs running in these cloud providers. And the emerging one that we have right now, which we are working on from a couple of previous releases, is using the software-defined cloud interconnect providers like the Megaport or Equinix, and use them as a transport again to connect to cloud workloads, or even to use them as a backbone for site-to-site connections, right? And now let's talk about how we approach our roadmap or vision, right? So this is, I have one more granular side, the typical roadmap slide there where you have all the bullets line by line. And then I have one high level theme slide, right? So just to make it easy for you, slightly easy. I understand it is again very busy, but and we are just capturing 3 releases here right now. 17.6, which was, or 20.6, which was out in August, then 17.7, which will be out hopefully in 1 or 2 weeks in December, as we are speaking, and then 17.8, which will be out in April, right? And then of course we have roadmaps. So what are the themes we are chasing in these releases, right? So at a high level, we have 3 or 4 verticals or 5 verticals, right? So one is of course the vManage. How do you monitor? How do you configure? How do you analyze, right? Analytics. That is one direction. Another is, of course, the core of the SD-WAN, the core infrastructure features, right? Your policies or your NAT or your multi-tenancy, right? Or your MIBs, anything like that. Then we have, of course, the cloud networking, where we have been the leader in the SD-WAN space, right? And then, of course, the SASE, the security, and other services like WAN optimization along with that, right? So essentially, these are the 4 verticals that we are chasing in our overall strategy, right? And then we shape our features as per that, right? Now, in each vertical, we have some high-level strategic initiatives. So in terms of vManage, we are focusing heavily on improving our UX experience. So we have ongoing initiative called UX 2.0, which basically we started delivering from 17.6, and you could have seen the change in the UI, the themes, and now we are improving it further. We are introducing concepts like config groups or tags, right? If you had a chance to work with cloud providers, so there is concept of tag, right, or label. Some people call it label. So similarly, we are introducing those concepts in our configuration philosophy also. So you can tag few things, right? You can, for example, we used to have templates. So now you can have config groups, and that you can apply to multiple devices, right? So basically simplifying the user experience in terms of configuration, right? And also providing you better analytics, better monitoring, better widgets, and all that, right? And also we are following what we call as cohesion principle. So what that means is when you move from DNAC to vManage, you should not see any difference in themes, UI themes or widgets, so the UX experience would remain same. So that is a principle we are following all across our products in Cisco. So that is a very big initiative going on with vManage. So every release starting from 17.6 has some features in that buckets, right? And it will continue in the roadmap also. Now, beyond that, of course, we are betting very big on 1000i integrations. So already some of the edge platforms have that integrated through 1000i containers, and we are going to enhance it further through vManage dashboards and further, right? Similarly, we are investing a lot on vAnalytics improvements also. Now, beyond this, on the vManage side, there is a lot of emphasis on, scaling up. So how many devices we can handle, right? So I think from past year or so, we have started publishing numbers on CCO from 17.3 or 17.4, if I'm not wrong, how many devices vManage cluster can handle, so that we get a better guidance to our field, to our partners, as to how to build our vManage and controller clusters, right? And that is a rich guidance in terms of we tell you how much data, how much flows and the vManage can handle, and then based on that, how many devices, how many vManage in a cluster, right? Those kind of things. So we are working on that, and we continue to improve on that. And that is not only from test perspective, there are some architectural level changes also going on in vManage to help us scale even better, right? So we are talking about 7,000 devices to 10,000 devices and so on, right? So, and that is not only restricted to single tenant, but also multi-tenant. So these 3, I would say, are the big themes when we talk about vManage and analytics, right? Now, similarly, on the SD-WAN core or infrastructure side, there are quite a few themes going on, right? Now, I will pick few of them, right? Direct internet access, as we know, right? It's a big thing. We ourselves, I myself, right now I'm talking to you, I'm not connected on VPN, right? I'm just using Webex through direct internet access, right? Because of obvious reasons, right? I don't want to introduce delay in my connection. Now, it's a big theme in enterprise networking, and we identify that, and we are continuing to enhance direct internet access features in our solution, right? Something like dual DIA connections, and also closing on all the other gaps, like supporting it on sub interface, dialer interface, all that, right? IPv6 is another big bucket, big initiative that we are chasing, right? There are mandates from federal governments with timelines, right? 2023 or so. So that how much percentage of federal network should be IPv6 ready, right? And we are chasing that big time, right? So from 17.7 onwards, you would see IPv6, big IPv6 features trickling in, right? Like DIA IPv6, DHCPv6, sending IPv4 traffic over IPv6 tunnel. Then we are talking about application-aware routing policies using IPv6, right? TLOC extensions, zone-based firewalls. All these are on roadmap. Some of them are on track to be delivered in 17.7 and 17.8. So IPv6 is a big initiative. We have a priority list of features for IPv6, which we are targeting to, the top 20 features in next 5-6 releases. So something like that we are targeting in our roadmap. Now, beyond this, there are two big buckets in core and infra. One is hierarchical SD-WAN, right? So we are rethinking about how SD-WAN is deployed in big networks, big enterprise networks, as well as how it is deployed by the MSPs, right? Where you can have multiple regions, right? And how do we connect our SD-WAN networks so that your application aware routing is truly effective end-to-end, right? Today, it is on a hop by hop basis, whatever we measure, right? Then basically we don't have visibility into the middle mile, right? How do we overcome that? That is where hierarchical SD-WAN comes into picture. Multi-tenancy is something we have invested big time starting from 17.4. We are increasing the scale. We are adding new features like disaster recovery, also advanced fairness, where we say that one tenant does not use up too many resources of tenant 2, right? Something like that. We are continuing to enhance the scale in multi-tenancy, and also we are working big time on multi-tenant edge. I believe in 17.7, if I'm not wrong, we already had some sort of initial phase of the feature released, and we are continuing to work on it on 8 and 9 and henceforth, right? So all these are core and infrastructure features. Now coming to the cloud networking. So as you might have seen already, right, we have put a lot of emphasis on cloud networking, right? So there are, I think, 3 or 4 different waves of work going on here, right? One is, of course, related to the SDCI providers, the Megaport or Equinix, right? We are working with them closely for using their backbone, right? And that is an alternative to MPLS, right? So that is one, or using their backbone to connect to the cloud providers itself. So, today, if you want to set up a direct connect, it takes, I think, 72 hours minimum for AWS to give you a letter of engagement or something they call it, right? But having integrations with these SDCI providers, you get a programmatic access to all these direct connect features provided by the cloud providers, right? So that is one theme. Another theme is working natively with the cloud providers, right? When you talk about Azure vWAN or recently announced AWS Cloud WAN or Google Network Connectivity Center. So we were one of the first partners to work with them on all these features, right? So we are working very closely with all the providers there. And at the same time, we are also working with the SaaS providers like Office 365. So we are getting telemetry from them and using that in our products to give you best path to reach Office 365. So that is another area we have identified of as a very high importance to our customers, right? And then then, of course, we are improving our cloud on-ramp SaaS offering, where we, in a general way, we used to provide figure out the best path for our SaaS applications, right? So we have added Webex as one of the supported app. We are going to support custom applications there. We are already supporting, we used to support it on direct internet links. Now we are going to support it on SIG tunnels also, right? And along with that, we are improving our dashboards in vManage for this multi-cloud, right? That is on roadmap. So cloud is, we can safely say it is one of the biggest focus areas for us in our roadmap, right? And the other big focus area is SASE, security, and other services, right? So you might have seen all the features which have been released in 17.6 related to Umbrella and Zscaler integrations, right? Or even slightly earlier releases. Now we are just going to improve on them. Our security policies for on-prem security, the zone-based firewalls. We have identified some of the feature improvements there, like how do you configure it, how to simplify it, right? So we are working on that, and we are working on the IPv6 stack also for on-prem security. And similarly, we are working on, identity-based, user identity-based enhancements in our SIG portfolio, right? And continuing on the other services, like we did DRE, which is, I think, duplication elimination or something related to the optimization, WAN optimization. So we did that in 17.6. Data redundancy elimination, something like that. And then we continue to work on WAN optimization features related to app QoE, voice features like Cube or SIP, and also on the, our virtual CP or universal CP offerings related to, CSP platforms, ENCS platforms, and also the hypervisor that runs on it, NFVIS. We continue to work on those services as well, right? So essentially, we are trying to cover what is important for customers across all these verticals. And having said that, there are certain big themes going on in all these verticals, right, as you can identify. So this is, I thought this might be more useful to you rather than the next slide, where we have line-to-line bullets, right, for each of the feature asks. And you can see some of these I already touched upon, right? Like in roadmap, again, you can see on vManage, there is UX 2.0, the UI initiative that we are running through across the releases, right? We are working on our DPI or scale enhancements across the releases with respect to vManage. We are also working on something called co-management, something which I skipped in previous slide. So basically, it's a feature targeted towards our MSP customers, where the MSP want to give some sort of autonomy to individual tenants, right? Like some of the, let's say some of the LAN side configurations, the templates, the tenant may want autonomy on that, right? Which routing protocol to run, and they don't want to go to MSP each time on that. So we are introducing those kind of RBAC enhancements, and we have the umbrella feature called co-management for that, right? ThousandEye continues to be a big theme across all the releases. Core and infra, I already touched upon the DIA enhancements. Again, we had some enhancements in QoS, like you can see per VPN QoS in 17.6 that got released. Then in 17.7, we are also introducing a nice feature called default AR and QoS, where we give you, industry standard AR policies and QoS settings, so that some customer who is lazy or who is not so tech savvy, right, they can straight away start consuming those policies rather than trying to configure them themselves. And they can of course tweak the parameters if they need. And IPv6 is again, there are some features in 17.7, 17.8, and 17.9 also. So 17.9 is, it's shown as roadmap here. So it is it is still getting finalized as we speak, right? So we are also trying to catch up on all the MIB parity, which was one of the few gaps remaining between C-Edge and V-Edge. So we will close that. So most of the features which were a gap on C-Edge are already covered in C-Edge now from V-Edge perspective. So for any future deployments, I think CH should be the way to go, because CH, as you can see, most of these enhancements, the cloud enhancement, security enhancement, as well as when we talk about scale, CH is much, much more powerful than VH. So that should be the logical reason for preferring CH here. And then in terms of security and services, of course, we have clubbed cloud along with the security here in the services bucket at the bottom. So SDCI continues to be the big theme. In 17.6, we released our integrations with Megaport with respect to Azure and GCP. We also released our integrations with Equinix for AWS, right? And also we had GCP related enhancements, right? So as you can see, 17.6 was big time on the cloud networking. Then of course we continue on Azure vWAN journey across the releases. 17.7 is vWAN phase 3, where we do some sort of auto scaling of the network virtual adapters in vWAN, and we continue on that journey in 17.8 and beyond, right? Similarly for Office 365 and other SDCI enhancements, right? So don't want to cover each and every line here, because I don't think that would be very useful. But again, I think if you want to take away something, these are the 3 or 4 buckets that we are pursuing in our roadmap. One is, of course, the vManage analytics, and we have some big themes going on there: UX 2.0, 1,000 eyes, and scale related enhancements. In SD-WAN core and infra, we have enhancement related to multi-tenancy, hierarchical SD-WAN, IPv6, and DIA. Those are the big themes. In the cloud, again, we have 3-4 big themes. We have SDCI integrations with Megaport and Equinix. We are working closely with the CSPs themselves, AWS, Azure, and GCP. And then we are also enhancing Office 365 natively, and as well as our cloud on-ramp SaaS, right? In terms of SASE and security, we are improving our offerings in SIG with the Umbrella and Zscalers, as well as our on-prem offering. And finally, we are continue to, evolve our WAN-opt features, AppQE, DRE, as well as voice offerings. So these are high-level themes across the roadmap if you want to take away from this session, right? So with that, I would pause here. If there are any questions, I'm happy to take it here or offline, as you suggest.
Thank you, Ajay. Maybe the questions may come up on the Q&A session. Maybe I would request you to wait for a few more minutes.
Okay.
And if there are any questions, please try to answer that.
Sure.
Thanks, Ajay.
Thank you, Guru.
And we are now coming to the last and final session, which is our tool, which is going to be very useful for every partners and customers, because we have seen in the past some scaling issue and upgrade issue on the vManage, which is going to get caught hold on this tool as a pre-checks. Maybe I'll hand it over to Javier for him to just present that and demo. Javier, over to you.
Thank you, Guru. Good morning. Could you give me share permissions?
Yep, I'm doing it right away. Yeah, thank you.
Thank you. Okay, people. Thank you and for being here and for the opportunity to explain this a little bit. And basically, what we have here is we wanted to create a tool to help customers on doing upgrade validation, on making it easier for doing an SD-WAN upgrade. We know SD-WAN upgrades are complex. You have multiple objects belonging to it. So you have the controller, you have the vManage, you have the edge routers that need to be upgraded. And we see that it is a very common case generator. Because there are so many elements involved, there are so many details that can happen. Upgrades are always complex, and they have a lot of details. So what we wanted to see, okay, we have a lot of learnings about how to do an upgrade. What can go wrong? What are the little details that we need to check before the upgrade? Not necessarily those details are part of the upgrade itself, but is sometimes what we see is the controller or the vManage may have something which is not healthy enough, something which is not going well. When you upgrade, things will not get better. Will go basically you will start seeing problems that were not obvious before. So we wanted to package all of those learnings we have on the different cases into a simple tool that you could use on the vManage by yourself to validate what is the health of the vManage systems before you do the actual upgrade. We limit ourselves on how this tool should be to ensure that you could copy-paste this tool into the vManage. You will not need any binaries, any special permissions, as simple as possible, and you should be able to execute it by yourself. We also wanted to support existing deployments, so we made it from 18.3 to 20.6 across a very large set of variations on cluster, not cluster, with disaster recovery, not disaster recovery, on ESX, on hypervisor, on AWS. So we wanted to cover all possible variations that are there. Of course, this also brings that the tool cannot generate a fancy reporting with graphics and PDF and things like that, because we are constrained by the Python subsystem that the vManage is offering. And we wanted to work from 18.3, so we had to use whatever is there. So the tool is simple. It will generate a text report and that's it. But the good thing is you can use it safely on any system by yourself. The tool is executed by somebody who has operator rights, can be read-only, doesn't need to be an administrator. Normally, it is the administrator who's going to execute it, but let's say read-only access will work. We also design it to be safe, so we don't do any overly complicated or expensive set of checks. For example, we don't want to go and talk to each one of the VHs to see what is the status, because that will be super expensive in terms of interactions over the control plane. So we used as much as possible data that is stored on the vManage itself. There is nothing written on the databases, nothing written on the vManage except the report and log files. That's it. So there is no changes. There is no information collected and sent forward to anybody else. There is no cloud tool that is going to be confirmed or validated or recording any data. So everything happens locally on the vManage and it stays on the vManage. So we wanted to make it constrained and simple for the end user. How it works is basically you go and install this script on the vManage itself. It will detect if it's running on cluster mode, and it will execute both API calls about each one of the components of the system, including the other cluster members, and it will execute as well Linux calls to validate information which is locally on the system you install it. How we will install it, the most typical is you copy the file by SCP, or you literally open the file on VI and copy paste the text into a file, and it's done. How you can download the tool is here in GitHub in the Cisco DevNet project page. It's called Sure. You can go there and download the source code and install it, copy paste directly. So it's completely open from our side. Execution is very simple. Basically, what you do is you go into a virtual shell, you call Python, and then the file name you put to the script, and then the user you want to execute. It will request you for the password. I will start executing the checks. How long it will take to execute the checks, you will see it depends. Everything is nice and cool. It will take you a few seconds. If there are some systems that are timing out or going slower, it will take some a couple minutes, but this is normally it's not going to take half an hour. So it's just a matter of minutes, and it's going to be completed. To get the results, you will see the tool generates two files and it prints the file names. One is the report itself that tells you what are the total checks that were executed, how long it took, and the overall evaluation. So there is things that you need to pay attention, or things that you can ignore, or you can live with them. And then you got the execution logs, which are the shoe logs as well, which will tell you the detailed information for each one of the checks in case you want additional information what went wrong. Each one of that's important, because sometimes the logs you want to check why it's reported, something like that, you can go and get additional data. You can of course call it with verbose or debug information to see more stuff printed, but normally with a report and the logs is enough to know what's happening. If you're running 25 or higher, the Python subsystem has been upgraded, so you need to call it with Python 3 short PI. If you fail to do so, the tool is just going to fail and tell you a message, hey, you need please try to do so. 24 and lower, you just write Python and the tool name. Now, what do we check? This is important. We try to split things in three levels, like a critical, which are things that you really should look into them before upgrading. Medium, which is, okay, this is something that may be impacting in some scenarios, not all of them. And then you have the info kind of level, which is, okay, something for you to know, and most scenarios will survive happily with them. It's no big deal. So all messages are split into these three categories. Now, some of them, the checks are very basic, but you will be surprised how frequently we see case failing because somebody didn't check this. For example, there is validation that both vManage, vBonds, vSmart all belong to the same versions before upgrading. Sometimes we have customers that had some vBond in the system which they forgot about and was running a non-compatible version. That can lead to problems. There is a version validation upgrade path, which means we will tell you from your current version to reach 20.3 or 20.6, which are the long life releases right now, which are the steps you need to go. So, for example, if you are in 18.3, it will tell you, okay, you need to upgrade to 19.2. Your partition size is correct, so you need to do anything fancy. You can move forward. So it will check what are your steps you require. We'll also validate disk space, in both data and rootfs. Memory size, it will use the hardware compatibility requirements for my vManage, and for example, you check the number of VHs against your CPU count, memory size. Also, if you have DPI or not. These two are fairly important when we are in on-prem scenarios. For on-cloud scenarios, this is already taken care by the cloud ops, but for on-prem, that's a common problem. Then we go into some other more fancy stuff. For example, StatsDB. It will check if index health and index versions. This may happen, for example, where people were upgrading from old releases, so 18.3, 17.3, towards new releases, and there is, for some reason, there is some index that was left without complete validation, complete upgrade. So when you move to 23 or higher, this was sometimes triggering problems. So this will find for you, so it will flag, and you can open a tag case to get this corrected. You get as well other scenarios, for example, vManage, all services are working, the NTP synchronization, are we having a correct cluster health? So in a sense that all members have the correct services up, all members can talk to each other over the cluster interface. It will validate your config DB if you have the correct number of members in case of a cluster scenario, messaging server if it is running across all systems. It will check as well, for example, network card type. We found some scenarios where using old OVAs to create on-prem was leading to incorrect cards, and that led into kernel panics. So this will validate that. Also for if you have this system's performance issues, it will also flag them. This is typical for using IDE on old images, all servers created by all OVAs as well. So you can detect them before they become a problem. This was very common. People migrating from 18.3 to 19.2. The performance requirements are higher a little bit. So things that were on the working but borderline on 18.3, when you upgrade, they deteriorate quickly. So this will flag them. So you can take preventive actions. We'll check certificate expirations, is the VH list is on sync. So these are, as you see, it's a collection of little details across all different subsystems on vManage. So we check. We have a common question here, which is, okay, is this tell me health? Is this like a checklist of things I need to do before upgrading? Can I use this as a regular monitoring of the vManage? So, well, it is not the intention. The tool is not designed to be run as a regular set of validations across time. It's like a spot check. Okay, today I'm healthy today. Yes, you are healthy. You can go ahead. That's it. There are other tools that are designed to do a more continuous and detailed monitoring of vManage, and some of them will be made available to customers in the near future, and we are working with Google on that. And they will be integrated with a short kind of checks. But okay, the tool is there. If you want to use it as a regular basis, it's fine for you to use. But the original objective was to do spot check before a major upgrade. Let me show you how the tool looks. And you would see this is relatively so. Basically, from the normal admin access, you will go to the vShell, and you will basically will execute the tool. The Python, remember, Python adjusted until 20.4, Python 3 and for 25 and higher. Yes, sir.
Sorry to interrupt you. Maybe we can make the font a little bigger. Yeah.
Make the font a little bigger. Okay, let me see if I can make that happen. Appearance, window, and where is my font? There you are, font. Let's make it 14. And I don't see it applied. Okay. Oh yeah, there you are. Better, or you need it higher?
Yep.
Bigger.
Yeah, maybe a little higher. Yeah.
Sure. Options.
Yeah,
it works?
This looks good. Yes.
Okay.
Thanks,
cool.
Xavier.
No problem. So remember, Python, if it's 24 and lower, Python 3 if you're 25 or higher, then and then the user you want to execute. And the user doesn't need to be admin. It can be a read-only operator. Cannot be a guest. You put your user password, and the tool will start executing. How long this is a system I put here is a 24 cluster that has problems on itself. So it will take a little bit longer for some of the checks to execute. And the idea is that, yeah, I wanted to have a system that has problems too, so you can see the reports and so on. It takes about a couple of minutes to execute. Not a big deal. There we are. So this is the tool has completed. It will tell you where the results are, and we can go here and to see here, and it tells you an overall view of how things are. So we want to see the report in detail. Just open it, and we see here. Okay, we have some critical issues. We have 26. Most of the check has passed, and 3 has failed. What do we have here? Okay. I have a system that has ZPA enabled and doesn't have the recommended memory size. Okay, so we want to flag it. This as well has a low CPU count, has 8, which is unsupported. It should be 32 higher based on the hardware requirements. And of course, we have DPA enabled. Our hardware recommendations doesn't match. If this is a scenario, this system doesn't have any Neo4j or any config.db or statsdb failure, so most of the things were fine. And then you can go ahead and check each one of the checks, what was the output, and if there was any problem. In this scenario, if you want to check more debugging data, we can go and print as well the logs. In case you have a failure, or in case you want to report us any kind of doubts, the logs are important because here you can see in all kind of details what was collected and what triggered the success or failure of the particular data. Okay, so right now the tool is standalone. You can go and download and use it as you need. We will be really happy to get any kind of feedback from your side. If you see the tool is useful, or we want to do additional checks, we have a couple that were reported recently, and we are planning to add in the coming weeks. And please provide your feedback. You can write to short-tool@cisco.com, and that will go directly to us, to the development team. So feel free to provide back any kind of feedback, recommendations, or issues you find. Okay, Guru, that's about it. Any questions on the QA?
Yeah, I don't see any right now. Probably we'll wait for a couple of minutes. Javier? Yeah.
Sure.
I think pretty much we are done. Thanks, Javier, for your session. That was really helpful. Yeah. So we will wait for a few more minutes, for you guys to raise any questions on Q&A session regarding the Aura tool.